In the beginning, there was darkness. Then, a whisper of light, ancient photons born from creation's first fire, still journeying across eternity to reach your eyes tonight. Every point of light you see above is a story billions of years in the making. As we drift among them, we are not explorers of space, but of time itself. Beyond the veil of stars lies the ultimate horizon, the edge of everything. But what happens when we reach it? What does it mean for something to have an edge, when infinity itself never ends? Like and subscribe, fellow traveller, and join us as we journey through the cosmos. Let's begin. From our small blue planet, we can see nearly 93 billion light-years of cosmic expanse. Yet, this is only what light has had time to reach us from. Beyond that horizon, the universe continues, endless, unseen, and expanding faster than we can ever chase. What we call the observable universe is not a true boundary, but a horizon of time. It marks the distance that light has travelled since the universe began, nearly 13.8 billion years ago. Every direction we look, up, down, east or west, is a glimpse backward through the deep well of cosmic history. The faintest galaxies at the edge of our sight are not distant in space alone, but in time. We see them as they were billions of years before Earth ever formed, their light only now arriving after a journey older than our species, older than our world. If you could stand outside the Milky Way and look inward, you would see a tiny sphere of light surrounding our galaxy, our own bubble of visibility. Everything within that sphere, every star, planet, and galaxy, is part of our observable universe. It stretches on, perhaps infinitely, into regions we will never see. These unobservable realms are forever beyond our reach, not because of distance alone, but because of the expansion of space itself. Space isn't static. It grows, stretching like a cosmic fabric. As it expands, distant galaxies are carried away faster than light can bring their images to us. They slip beyond our horizon, lost not in darkness but in time. Imagine space as an ocean, and light as ripples spreading across its surface. The further the ripples travel, the more the ocean itself expands beneath them, stretching their waves thinner and redder until they fade entirely. That fading is what astronomers call redshift, the stretching of light by the universe's expansion. Every time you look at the night sky, you're seeing the evidence of this great cosmic stretching. The universe isn't just expanding, it's accelerating, driven by something we barely understand. Dark energy, a mysterious pressure that seems to push galaxies apart faster with each passing eon. The result is a cosmic paradox. The farther we look, the younger everything becomes. Light from the edge of visibility shows us a universe still in its infancy, a glowing fog of newborn galaxies, forming stars in bursts of creation. To look outward is to look backward. Every telescope becomes a time machine, every photon a messenger from the ancient past. And one day, that past will vanish. As the expansion continues, even galaxies we can see now will drift beyond our cosmic horizon. Their light will never reach us again. The universe will seem to grow smaller, dimmer, quieter, as the night sky slowly empties over the course of trillions of years. Future civilizations, if any survive that long, may look into the heavens and see only darkness, unaware that their cosmos was once filled with light. The observable universe is a fragile gift. It is the visible echo of creation, a fleeting window into infinity. We exist in a brief era when the cosmos still reveals itself, when light from distant worlds still crosses the dark ocean of space to find us. And perhaps that is the most humbling truth of all, that in this vast expanding void, we are not just observers of the universe, we are its witnesses, alive in the only moment when it can still be seen. Light travels at 186,000 miles per second, yet in the grand stage of the cosmos, even this speed is slow. Every beam we see tonight is ancient, ghostly memories of stars that may no longer exist. It feels impossible to think that something moving that fast could ever be considered slow. A single second of light's journey could circle our planet 7 times. In 8 minutes, it crosses the 93 million miles from the Sun to Earth. Yet when it comes to the cosmic scale, distances measured not in miles but in light years, light itself becomes a patient traveler. It drifts through the void like a message in a bottle, carrying whispers from worlds long gone. When you gaze up at the night sky, you're not seeing the universe as it is, but as it was. The light from the moon left just over a second ago. Sunlight began its journey minutes earlier, but the faint glow from the Andromeda galaxy left over 2 million years in the past, when early humans were just learning to shape tools from stone. Every star above is a relic, a snapshot from a different moment in cosmic history, frozen in transit across the great dark ocean of space. Light has a limit, an unbreakable cosmic speed law. Nothing with mass can surpass it. Space and time themselves bend to preserve it, as if the universe were woven around that constant. Einstein showed that light speed is not just a number, it is the foundation upon which reality is built. It defines what can be known, what can be seen, what can ever reach us. Beyond it lies only silence. And yet, even light can be slowed, not by losing speed, but by the expansion of the universe. As space stretches, the waves of light stretch too, growing longer, redder, weaker. The universe steals its energy, turning brilliant starlight into faint whispers of heat. One day, the most distant galaxies will recede so quickly that their light will never reach us. They will slip beyond the cosmic horizon, their glow stretched into invisibility. The sky, once filled with countless stars, will dim forever. Light, for all its speed, is fragile. It can be swallowed by dust, bent by gravity, devoured by black holes. It can travel for billions of years, only to be absorbed by a single atom, ending a journey older than entire civilizations. Yet despite these odds, enough of it survives to illuminate our skies, to reach our eyes, to tell us the story of everything that has ever been. Each photon that lands on your skin tonight began its journey before you existed, before Earth, even before the Sunday. You are touched by ancient light, carrying the memory of creation itself. Every flicker in the heavens is a time capsule, a delicate echo of an age long past, whispering across eternity that distance and time are one. And so, every time we look up, we are not just seeing stars. We are catching the universe in motion, watching history still racing toward us at the only speed the cosmos will allow. When we gaze at distant galaxies, we're not looking across space but backward through time. Each layer of the cosmos is a page in the universe's autobiography, written in the language of light. Every star you see is both present and past. Its light began a journey that might have started before humanity took its first breath, before Earth even solidified from molten rock. When we look out across the night sky, we are witnesses to history still unfolding in reverse. The nearest star systems show us what was happening just years ago, while the faintest galaxies, those faint smudges barely visible to our most powerful telescopes, reveal moments that took place billions of years before life arose on our planet. Time and space, it turns out, are not separate. They are woven together into a single fabric, space-time. When we travel through space, we also move through time, and the light that reaches us carries both distance and memory. It takes light 1 second to cross the space between Earth and the Moon. It takes 8 minutes to reach us from the Sunday. But to cross the observable universe, it would take nearly 14 billion years, longer than the entire history of everything we know. This means that when astronomers look deeper into the cosmos, they are effectively building a time machine. The Hubble and James Webb Space Telescopes do not just see far, they see anciently. In their images, the youngest galaxies appear as faint, red smudges at the edge of visibility, their light stretched by the expansion of space. These galaxies existed when the universe was only a few 100 million years old, a fraction of its current age. Their glow is the fossilized light of creation itself. But this journey through time is also a journey through change. The further back we look, the more primitive the cosmos becomes. The first stars were enormous and short-lived, fusing hydrogen into heavier elements that would one day form planets, oceans, and life. Each successive layer of light reveals a new chapter in the cosmic story, how the universe grew from simplicity into complexity, from darkness into brilliance, from chaos into structure. And as we peer further outward, the boundary between distance and time begins to blur completely. The edge of what we can see is not just the farthest point in space. It is the beginning of time itself, when the first light broke free from the dense, hot fog of the early universe. Beyond that, there is only darkness, the unlit era before stars were born. To look across the universe is to look into the mirror of eternity. The photons that strike your eye tonight began their voyage long before you existed, crossing billions of years to deliver a single fragile moment of illumination. You are seeing light that left its source before Earth's oceans formed, before galaxies spiraled, before time itself found its rhythm. And in that realization lies something profound. Every glance into the night sky is an act of time travel. Each star is not where it appears, but where it once was. Each glimmer is a cosmic memory, still making its way home. To see the universe at all is to stand at the intersection of distance and time, where the ancient past and the fleeting present meet in a single breath of light. Invisible filaments of dark matter stretch like strands of silk, connecting galaxies into vast clusters and voids. This is the universe's skeleton, a network of gravity weaving light and darkness together. When astronomers first mapped the large-scale structure of the cosmos, they expected a random scattering of galaxies spread evenly through space. What they found instead was astonishing. Galaxies were not distributed like grains of sand in a desert, but like dew on a spider's web, gathered along invisible filaments that spanned hundreds of millions of light years. Between these filaments yawned enormous cosmic voids, regions so vast and empty that if our entire Milky Way drifted inside one, we might never see another galaxy again. These filaments form what scientists now call the cosmic web, the grand architecture of the universe. It is a structure so large that even light, racing for billions of years, has not yet crossed from one side to the other. The galaxies, clusters, and superclusters we see are merely the glowing nodes of this immense network, strung together by threads of something we cannot see, dark matter. Dark matter is the hidden glue of creation. Though it makes up about 85% of all matter in the universe, it neither emits nor reflects light. We cannot see it directly, but we can trace its influence. It bends the path of light from distant galaxies, creating subtle distortions that reveal its presence. It anchors galaxies in place, preventing them from flying apart as they spin. Without dark matter, the universe as we know it would simply not exist. Imagine it like this. The early universe was a sea of tiny fluctuations in density, ripples in the cosmic ocean. Gravity pulled matter into the denser regions, forming filaments and knots that grew over billions of years. Hydrogen and helium followed, condensing into galaxies along these threads. In a sense, every galaxy we see is a drop of light caught in the invisible strands of dark matter's web. On the largest scales, the cosmic web looks eerily organic. Computer simulations reveal patterns that resemble neurons in a brain or veins in a leaf. Each node, each galaxy cluster, is connected to many others through delicate bridges of dark matter, pulsing with energy and motion. In some ways, it is as if the universe itself is alive, its vast network humming with gravitational tension, evolving and growing like a living organism. Between these luminous strands lie immense cosmic voids, regions so empty they defy imagination. Some stretch over 300 million light-years across, containing only a handful of galaxies adrift in darkness. And yet, even in their emptiness, they play a role. The voids push matter toward the filaments, sharpening the structure of the web, light and darkness working together in perfect cosmic balance. If you could somehow step back far enough to see the universe from beyond, you wouldn't see isolated galaxies or stars. You would see a glowing tapestry, a grand lattice of light woven through invisible strands of gravity, shimmering like a frozen explosion caught in motion. And perhaps, as you looked upon it, you'd realize something quietly profound. The same forces that thread galaxies together are the ones that hold atoms in your body. You are woven into that cosmic web. Every particle of you was once part of its ancient strands. To look up at the night sky is not just to see the universe, it's to glimpse the structure of existence itself. Each galaxy is a metropolis of suns, some with billions of stars, others just a handful. From afar, they shimmer like floating islands in a cosmic ocean, each one a cradle for unknown worlds. Our Milky Way is one such city, a sprawling spiral of over 400 billion stars rotating around a supermassive black hole at its heart. Its arms are rivers of light, streaming with star clusters, nebulae, and interstellar clouds where new suns are constantly being born. If you could drift above it, far into intergalactic space, you would see its spiral arms glowing softly against the blackness, like a city seen from orbit, illuminated by countless points of starlight. But the Milky Way is only one among trillions. Some galaxies are vast and grand, their shapes perfectly symmetrical, their arms elegantly curved. Others are irregular, distorted by ancient collisions or gravitational tugs. Elliptical galaxies, glowing like giant pearls, contain the oldest stars in the universe, quiet, ancient cities where star formation has long since ceased. Then there are dwarf galaxies, faint and fragile, containing only a few million stars. They are like cosmic villages, orbiting their larger neighbors as satellites in an endless dance. Every galaxy tells a story of time and motion. They are born from the collapse of vast clouds of gas and dark matter, growing over billions of years through collisions and mergers. When galaxies collide, they don't crash in fiery explosions as we might imagine. Instead, they pass through each other in slow, silent ballets. Their stars rarely collide, but their gravity tears and reshapes them. Arms stretched, cores distorted, star formation reignited. It is through these cosmic mergers that new galaxies are forged and old ones reborn. If we could map them all, the universe would appear as a grand metropolis of galactic cities, connected by invisible highways of dark matter. In dense regions, galaxies cluster together by the thousands, orbiting one another in cosmic superclusters. Between them stretch the vast intergalactic voids, deserts of space so immense that entire galaxies would appear as mere dust motes scattered across their horizon. Within these galactic cities, there are stars of every kind, blue giants burning with blinding intensity, red dwarfs glowing faintly for trillions of years, and yellow stars like our Sun, quiet, life-giving beacons surrounded by families of planets. Around many of these stars orbit worlds still unknown, each one potentially home to oceans, mountains, or alien skies. When you look up at the Milky Way on a clear night, what you see is only the inner glow of our own galactic city, seen from within one of its spiral arms. The dark bands cutting through it are rivers of interstellar dust, obscuring distant starlight. Yet even those dark regions are not empty. They are nurseries, where new stars are forming at this very moment. Galaxies are the universe's great civilizations, billions of suns, billions of potential stories, each evolving across cosmic time. And perhaps, scattered among them, there are other eyes looking back, other beings standing beneath other skies, gazing upward into their own night, wondering if anyone else is out there. To contemplate the galaxies is to realize that we are part of a vast and living cosmos, a universe of luminous cities floating in eternal darkness. Every beam of starlight that reaches us is a message from one of those faraway cities, a distant hello across the great cosmic sea. Cosmic background radiation hums softly through space, an ancient afterglow left from the birth of everything. It's the universe's oldest whisper, still echoing from the Big Bang. Nearly 14 billion years ago, the universe was not filled with stars or galaxies, but with fire. In its earliest moments, Everything was compressed into a dense, searing plasma of energy and particles, a blinding sea of light that could not escape its own brilliance. Photons, the particles of light, collided constantly with matter, scattering endlessly in all directions. There were no shadows, no silence, no empty spaces, just radiant chaos. Then, roughly 380,000 years after the Big Bang, the universe began to cool. The temperature dropped to around 3,000 degrees Kelvin, cool enough for protons and electrons to combine into neutral atoms. For the first time, light was free to travel without being trapped. In that instant, the universe became transparent, and the first true light burst forth across the cosmos. This light has never stopped traveling. It has been stretching and fading for nearly 14 billion years, expanding with the universe itself, its once blinding glare now softened into a faint, invisible glow that fills all of space. We call it the cosmic microwave background, or CMB. It is not the light of stars, but the light before stars. A fossil of the universe's creation, it still bathes every corner of the cosmos with astonishing precision. If you tune a radio between stations, about 1% of the static you hear is that ancient light, echoing faintly from the beginning of time. Discovered accidentally in 1965 by radio astronomers Arno Penzias and Robert Wilson, this forgotten light confirmed one of the greatest ideas in science: the Big Bang Theory. What they first mistook for interference or bird droppings on their antenna turned out to be the oldest signal in the universe, a snapshot of the cosmos as a newborn. The CMB is astonishingly uniform, the same in every direction, a near-perfect glow of microwave radiation. But it isn't entirely smooth. Tiny fluctuations, differences in temperature no greater than a few millionths of a degree, are scattered across its surface. These minute ripples are the fingerprints of creation. They are the seeds from which all galaxies, stars, and planets would eventually form. In those slight variations of ancient light, we can trace the blueprint of the entire universe. Today, satellites like the Planck and WMAP missions have mapped this light in exquisite detail, revealing a cosmic portrait of breathtaking simplicity and power. From this faint afterglow, scientists can measure the age, shape, and composition of the universe itself. It tells us that space is flat, that dark matter outweighs visible matter 5-1, and that dark energy drives the cosmic expansion faster each day. All of that from a whisper of light born billions of years before Earth existed. And yet, this light remains everywhere, flowing through you right now, passing invisibly through your body, through the walls, through the air, through every atom. It is the universe's most enduring memory, the afterimage of its own birth. When you close your eyes beneath the stars, that faint warmth of cosmic background light still touches you. You are bathed in the same radiance that once filled the infant cosmos. It is the oldest light you will ever feel, the first dawn, still glowing softly across eternity, reminding us that the universe, in all its vastness, remembers where it came from. The galaxies aren't flying through space. Space itself is stretching, carrying them apart like ink drops spreading through water. The farther we look, the faster they flee. For most of human history, we believed the universe was static, unchanging, eternal, infinite in its calm perfection. Even Einstein once thought so, adjusting his equations to keep the cosmos still. But the universe, as it turns out, is anything but still. In the early 20th century, astronomer Edwin Hubble noticed something extraordinary. When he looked at distant galaxies through his telescope, he saw that their light was stretched, shifted toward the red end of the spectrum. It was as though the galaxies were receding from us, fleeing into the distance. The universe wasn't static at all, it was expanding. This revelation changed everything. The light from distant galaxies isn't red because they're moving through space, it's red because the space between us and them is stretching. Imagine dots drawn on the surface of an inflating balloon. As the balloon expands, the dots drift farther apart, not because they're moving on their own, but because the fabric beneath them is stretching. The same is true of the cosmos. The galaxies themselves are mostly stationary within their local clusters, but the space separating them is growing larger with every passing moment. Every second, the universe expands a little more, an invisible stretching that takes place everywhere all at once. The very distance between atoms in distant galaxies increases, though on small scales the effect is imperceptible. It is only across vast intergalactic gulfs that this cosmic motion becomes profound. Over billions of years, the expansion has transformed a dense, hot universe into the sprawling tapestry of galaxies we see today. And the most astonishing discovery came when scientists realized that this expansion isn't slowing down, it's accelerating. Something mysterious, a form of energy that seems to permeate the vacuum of space itself, is pushing the universe apart faster and faster. We call it dark energy. And though it makes up nearly 70% of the cosmos, we have no idea what it truly is. It is the silent engine of expansion, a force that defies our understanding of physics. If the expansion continues indefinitely, galaxies far beyond our local cluster will eventually slip beyond our reach. Their light will never reach Earth again. The night sky will grow emptier with each passing eon, until only the faint glow of our neighboring galaxies remains. Billions of years from now, even that light will fade, and future civilizations, if any endure, will live in a lonely cosmic island, unaware that other galaxies ever existed. This is the quiet poetry of the universe's motion, an endless unfurling of space, carrying worlds and stars like petals on a rising tide. It is not an explosion from a single point, but an expansion of everything, everywhere. There is no center, no edge, only the steady rhythm of growth, an eternal deepening of distance. Even now, as you sit on this small planet circling an ordinary star, the universe around you is stretching in every direction. Galaxies drift farther away. Light elongates, its wavelengths pulled thin by time itself. And though we may never feel it, we are passengers on this vast expanding sea, sailing outward with every heartbeat, carried by the quiet breath of the cosmos as it grows, endlessly into forever. The deeper we gaze, the redder the light becomes, stretched by the expansion until it fades into darkness. Beyond a certain point, galaxies disappear entirely, lost beyond the cosmic horizon. Every beam of starlight carries a secret. Its color is not fixed, but shaped by the motion of the universe itself. When an object moves toward us, its light shifts to shorter, bluer wavelengths. When it moves away, its light stretches to longer, redder ones. This effect is called redshift, and it is one of the clearest signs that the cosmos is expanding. The farther a galaxy lies from us, the more its light has been stretched during its journey across the swelling fabric of space. What begins as brilliant white or blue light leaves its home galaxy full of energy and color. But as it travels for billions of years, the universe itself expands beneath it, lengthening its waves, dimming its hue. By the time that light reaches our telescopes, it may have shifted deep into the red part of the spectrum, or even farther, into the invisible realm of infrared and microwaves. The most ancient light, born near the dawn of time, has been stretched so dramatically that it has become nearly undetectable, faint as a dying breath. Astronomers use redshift like a ruler made of time. By measuring how much a galaxy's light has been stretched, they can calculate how far away it is and, more profoundly, how long its light has been traveling. A galaxy with a high redshift is not merely distant, it is ancient. Its light began its voyage when the universe was young, and what we see now is a glimpse into that faraway epoch frozen in light. But this cosmic stretching carries a melancholy truth. As the expansion of space accelerates, some galaxies are carried away faster than light itself can bridge the distance between us. Their photons will never reach our eyes. They slip beyond what we call the cosmic event horizon, a boundary beyond which communication, sight, or contact is forever impossible. It is not a wall in space, but a limit in time, the edge of what can ever be known. This means there are galaxies that exist right now, vibrant and full of stars, that we will never see. Their light, once aimed in our direction, is being stretched infinitely, fading into the black sea of the unobservable. They are not destroyed. They are simply lost beyond reach, sailing forever away on the expanding tide of space-time. If you could look far enough, beyond that invisible horizon, you wouldn't find the end of the universe, only the end of visibility. The galaxies continue, scattered endlessly through the dark, but their light can no longer catch us. It's as though we stand on a cosmic shore, watching ships sail over the horizon, their lanterns dimming until they vanish. They still exist out there, beyond sight, but for us, they are gone. And as time passes, that horizon creeps ever closer. More galaxies slip away. The universe grows quieter, lonelier, dimmer. One day, countless eons from now, the only galaxies visible will be those bound to our own by gravity, the local group, adrift in an otherwise empty void. So when you look into the night sky, remember, the stars and galaxies you see are only the ones whose light could outrun expansion long enough to reach you. Everything else lies beyond the vanishing horizon, their colors stretched into silence, their light fading into eternity. There exists a boundary where light will never reach us. Beyond it lies the unobservable, regions of the universe cut off forever, expanding faster than light can escape. It's a strange and humbling truth. The universe has horizons. Not like the curved edge of the Earth where sea meets sky, but horizons of time and physics, barriers that no amount of technology or imagination can ever cross. This boundary, known as the cosmic event horizon, marks the ultimate limit of what we can ever see, touch, or know. It's not the edge of the universe itself, but the edge of visibility, the point beyond which light, no matter how fast it travels, will never find its way to us. To understand why, imagine space not as a static backdrop but as something alive, constantly stretching, expanding, accelerating. Every second, the distance between galaxies grows larger, carried apart by the swelling fabric of space-time. The farther apart two galaxies are, the faster this expansion pushes them away from each other. Eventually, the rate of expansion between us and those distant galaxies exceeds the speed of light. Their light can no longer bridge the widening gulf. From that moment onward, they are lost to us forever. This doesn't mean those galaxies cease to exist. They continue their lives beyond the horizon, forming new stars, orbiting black holes, and creating worlds we'll never see. But their light, their stories, can no longer reach our eyes. In a sense, they've fallen out of the universe we can experience. It's as if reality itself is fading beyond our perception, the cosmic stage forever growing while the lights go out behind the curtain. The James Webb Space Telescope peers into the earliest light, but even it has limits. The light it captures has spent nearly 14 billion years crossing. Expanding space, stretched thin, redshifted into infrared. Beyond that faint horizon of ancient glow lies darkness, regions of the cosmos forever hidden, unreachable even in theory. The universe is not only vast, it's partly unknowable, an infinite expanse where sight itself has an expiration date. And this horizon is not fixed, it changes over time. In the early universe, when galaxies were closer together, more of the cosmos was visible. But as dark energy continues to drive the expansion, that horizon recedes. More galaxies drift away, their light stretched beyond detectability. The cosmos is dimming, not because it's dying, but because it's running away faster than we can chase. Someday, far in the future, the night sky will look utterly different. The great constellations we know will dissolve. Distant galaxies will vanish one by one, their light swallowed by the expanding dark. Future astronomers, living in a time billions of years from now, may look into the sky and see only the fading remnants of our local group. The Milky Way and Andromeda merged into a single island of stars, floating in infinite blackness. They will never know there was once a vast universe beyond their reach. The end of sight is not an apocalypse, it is the natural destiny of an ever-expanding universe. We are fortunate to exist in the rare cosmic moment when the stars still shine, when light from the farthest reaches still brushes against our world. For now, the universe remains open to our gaze, its horizons still glowing faintly with ancient light. But the darkness is coming, slowly, silently, and when it arrives, it will not be the end of everything, only the end of what can ever be seen. Before galaxies, before even planets, came the first stars, titanic beacons that forged the first elements in their burning hearts. When they died, they seeded the cosmos with the materials that would one day form everything we know, worlds, oceans, and even us. In the beginning, the universe was dark. For nearly 100 million years after the Big Bang, space was filled with a thin, featureless fog of hydrogen and helium. There were no stars, no galaxies, only vast silence and cooling gas stretching endlessly in every direction. Astronomers call this the cosmic dark age, a time before light itself returned to the universe. But gravity, patient and persistent, was already at work. Slowly, almost imperceptibly, it gathered the gas into denser and denser clumps. In those invisible cradles, the first stars were about to be born. When the first of them finally ignited, the universe changed forever. These were no ordinary stars like our Sun. They were giants, hundreds of times more massive, burning millions of times brighter. Their cores roared with nuclear fire, fusing hydrogen into helium and creating the first heavy elements. The light they cast was the first illumination in a cosmos that had known only darkness. For the first time, the universe could see itself. We call these pioneers Population 3 stars, a name that hints at their mystery because we've never seen one directly. They existed only briefly, living fast and dying young. Within a few million years, their immense energy exhausted their fuel. Some collapsed into black holes, while others ended in cataclysmic explosions, supernovae so powerful that they tore apart their surroundings, scattering their ashes across the void. In those ashes were the first elements heavier than helium, carbon, oxygen, nitrogen, iron, the raw ingredients for everything to come. The light from those first explosions raced outward, igniting the fog of the early universe and marking the end of the cosmic dark age. Slowly, the radiation from these newborn stars began to strip electrons from atoms, turning opaque hydrogen into transparent space. This process, called reionization, opened the cosmic curtains, allowing light to travel freely once more. The darkness lifted, and the universe awoke. Out of the ashes of those first giants came the next generation of stars, smaller, steadier, longer-lived. They gathered into clusters and began to form the first primitive galaxies. Over billions of years, those galaxies would merge and evolve into the grand spirals and ellipticals we see today. The Milky Way itself was built from countless such collisions. Its stars descended from that first generation of light. Though the first stars have long since vanished, their legacy endures in every atom around you. The calcium in your bones, the iron in your blood, the oxygen you breathe, all of it was once forged in the furnace of a star that died before Earth existed. You are, quite literally, made of stardust from that ancient generation. The first stars were the universe's great awakening, its first attempt to organize chaos into brilliance. Their light may be gone, their embers long cooled, but their fingerprints remain everywhere, in the galaxies that followed, in the elements that compose us, and in the night sky that still glows with their distant echoes. In their brief burning lives, they transformed a cold, dark cosmos into a living, luminous one. And in doing so, they made everything possible. Gravity gathered clouds of gas and dust into spinning disks, birthing galaxies that glittered like newborn jewels against the blackness of the early universe. Once the first stars lit the dark, their gravity began to pull their neighbors together. Clusters of stars and gas coalesced into swirling formations, embryonic galaxies that would one day become the vast, complex systems we see today. It was a time of cosmic adolescence, when the universe was less than 1 billion years old, and the laws of gravity were quietly sculpting its grand architecture. What began as small, faint gatherings of light would evolve into the colossal spirals and ellipticals that now fill the heavens. Each galaxy began as a seed of dark matter, invisible halos that anchored the flow of cosmic gas. Within these halos, hydrogen and helium condensed into dense clouds. When the pressure became great enough, stars ignited, first a few, then thousands, then billions. Over time, these young stars organized themselves into rotating structures, drawn together by the delicate balance between gravity and motion. From these primordial whirlpools of light, the first galaxies emerged. The earliest galaxies were small and irregular, more like chaotic bursts of light than the graceful spirals we know. They collided often, merging into ever larger systems. Each collision was a slow-motion dance that lasted millions of years, creating turbulence, igniting new waves of star formation, and shaping the universe's growing complexity. The galaxies we observe today, majestic, stable, and immense, are the descendants of those ancient mergers, the survivors of cosmic evolution. Deep in the images captured by the James Webb Space Telescope, we can still see these ancient galaxies as they once were. Their faint light has traveled across nearly 14 billion years of expanding space to reach us. They appear as soft red smudges, tiny in size, but unimaginably distant. Each one is a message from a time when the universe was still learning how to shine. In those delicate clusters of light lies the history of creation itself. As galaxies grew, their shapes diversified. Some became spiral galaxies, their arms winding gracefully around glowing centers, like the Milky Way. Others became ellipticals, vast ovals of ancient stars, glowing with quiet dignity. Still others became irregulars, distorted by gravitational encounters, their forms twisted by unseen forces. No two galaxies are exactly alike, and yet all are bound by the same physical laws, the same invisible threads of dark matter and gravity that guide their evolution. Galaxies are more than collections of stars, they are cosmic ecosystems. Within their arms and cores, stars are born, live, and die, recycling their matter into new generations. Gas clouds collapse into new suns, while supernovae enrich the interstellar medium with heavy elements. Over billions of years, this cycle creates the conditions for planets, chemistry, and life. Each galaxy, in its own way, is a cradle of potential, a vast, glowing laboratory for the universe's endless experiments in creation. When you look up at the Milky Way stretching across the night sky, you are gazing from within one of these galactic cities, a structure so immense it takes over 200 million years to complete a single rotation. Yet it too was born from that same cosmic process, billions of years ago, when gravity first gathered light into order. The birth of galaxies was not just the creation of structure, it was the birth of beauty, the transformation of chaos into symmetry. In those first luminous gatherings, the universe began to take shape, to organize itself, to dream in spirals and spheres. And even now, billions of years later, galaxies continue to form and evolve, each one a living testament to the power of gravity and the patience of time. At the heart of nearly every galaxy lies a supermassive black hole, an invisible engine of creation and destruction, shaping the stars that orbit around it. To imagine a black hole is to confront one of nature's most astonishing paradoxes. It is both nothing and everything, a place where gravity grows so fierce that space and time themselves collapse inward. No light can escape its pull. No signal can return once it crosses the event horizon, the boundary between what can be known and what must remain forever hidden. Yet despite their darkness, black holes are among the brightest objects in the universe, their presence revealed by the radiant storms of energy they unleash upon the matter around them. At the center of our own Milky Way lies one such titan, Sagittarius A*, a supermassive black hole containing over 4 million times the mass of the Sun. Though it hides behind clouds of gas and dust, astronomers have traced its existence through the orbits of nearby stars, which move at unimaginable speeds around an apparently empty point in space. In 2022, humanity captured its shadow for the first time. A glowing ring of hot plasma swirling around the abyss, revealing the face of the cosmic heart that binds our galaxy together. but Sagittarius A times is modest compared to others. Some galaxies harbor black holes billions of times more massive than our Sun, devouring matter at such ferocious rates that they outshine entire galaxies. These blazing beacons, known as quasars, were common in the early universe. Fueled by infalling gas, they lit up the darkness of cosmic dawn, broadcasting energy across billions of light years. From their furious centers, the universe's first great light shows were born. How do such monsters come to be? The truth is still a mystery. Some may have begun as the collapsed remnants of the first massive stars, growing over time as they swallowed gas, dust, and even other black holes. Others may have formed directly from immense clouds of primordial matter, skipping the stellar stage entirely. Whatever their origin, they have been with the universe almost from the beginning, silent architects shaping the structure of galaxies themselves. Despite their reputation as cosmic destroyers, black holes are also creators. Their immense gravity regulates the birth of stars, compressing gas in some regions while preventing it from forming in others. Jets of charged particles, launched from the swirling disks around them, can stretch across hundreds of thousands of light years, energizing interstellar gas and triggering new waves of creation. In a strange balance, destruction feeds creation, and silence gives rise to light. Around every black hole, time moves differently. To an outside observer, anything falling toward it appears to slow down, frozen forever at the edge. From within, however, time races forward to an inevitable end. The very concept of before and after breaks down. Black holes are where the universe tests the limits of reality, where Einstein's relativity and quantum mechanics collide, where physics itself begins to unravel. And yet, without them, galaxies might never have formed as we know them. They are the gravitational anchors of the cosmos, stabilizing the orbits of billions of stars and shaping the galaxy's very architecture. In their silent depths, the balance of creation is maintained. Perhaps the most poetic truth is this: the thing we cannot see, the ultimate darkness, is what holds everything together. At the center of every galaxy, and maybe even at the center of every mystery, there lies a singularity, an unseen force that binds the stars, the worlds, and the fabric of existence itself. Though unseen, dark matter outweighs all visible stars combined. It bends light, sculpts galaxies, and dictates the cosmic architecture, an invisible artist shaping everything we see. When we look at the universe, we see only a fraction of what truly exists. The stars, nebulae, and galaxies that fill our telescopes, the glowing threads of the cosmic web, make up less than 5% of the universe's total matter and energy. The rest is hidden, silent, and invisible. Dark energy drives the universe's expansion, but dark matter gives it form. It is the scaffolding upon which the cosmos is built, unseen yet indispensable. Dark matter reveals itself not through light, but through gravity. In the 1930 seconds, astronomer Fritz Zwicky was among the first to suspect its presence. While studying the Coma Cluster, a vast congregation of galaxies, he noticed that the galaxies were moving too fast to be held together by their visible mass. Something unseen, something far heavier, was providing the gravitational glue. Decades later, astronomer Vera Rubin confirmed the same pattern within individual galaxies. Stars at the edges orbited far faster than they should have if only visible matter existed. The conclusion was inescapable. Most of a galaxy's mass is invisible. But what is it? Dark matter neither emits, absorbs, nor reflects light. It passes through ordinary matter as though it isn't there, and yet it exerts a powerful gravitational pull, enough to shape the motion of stars, to bind galaxies into clusters, and to bend the very path of light itself. We see its fingerprints everywhere, in the way galaxies rotate, in the bending of starlight through gravitational lensing, and in the cosmic web's vast network of filaments. Without it, the universe as we know it could not exist. Imagine the cosmos as a vast, invisible sculpture. Dark matter is the framework, the hidden structure beneath the visible surface. It formed first, collapsing under its own gravity to create halos, dense regions where ordinary matter could gather. Within these halos, gas cooled and condensed, birthing the first stars and galaxies. In essence, dark matter created the stage on which light could perform. We have mapped it, in part, through its gravitational effects, but we have never touched it, never trapped a single particle of it. The leading theories suggest it could be made of exotic particles that interact only through gravity and the weak nuclear force. WIMPs, axions, or perhaps something even stranger that we haven't yet imagined. Experiments buried deep underground and in space are searching for its faint signature, hoping to catch a glimpse of the unseen majority of the cosmos. So far, it remains a perfect enigma. And yet, we can see its hand at work. Gravitational lensing, where light from distant galaxies is bent and magnified by massive objects, has revealed the ghostly outlines of dark matter's presence. By mapping these distortions, astronomers have traced the invisible, vast halos surrounding clusters, filaments stretching across millions of light years, and dark voids where almost nothing exists. It's like seeing the shadow of something that has never been illuminated. Dark matter is the quiet sculptor of the universe. It shaped galaxies, guided their dance, and continues to influence the expansion of everything. We owe our existence to this unseen mass, to a cosmic hand that does not shine but holds the stars in place. Perhaps one day, we will understand what it truly is. For now, it remains the great mystery of modern cosmology, proof that the most powerful forces in the universe may not be those we can see, but those that work in silence, hidden beneath the surface of reality itself. Something unseen drives the universe's expansion faster and faster. This mysterious dark energy is like a silent wind pushing galaxies apart, an enigma that may decide the universe's fate. In the late 1990 seconds, astronomers made a discovery that shook our understanding of everything. They were studying distant supernovae, exploding stars whose brightness could be used to measure cosmic distances. By comparing how fast these galaxies were receding, scientists expected to find that the universe's expansion was slowing down under the pull of gravity. Instead, they found the opposite. The expansion was accelerating. Somehow, the cosmos was not winding down, it was speeding up. To explain this baffling observation, scientists proposed the existence of something they called dark energy, a mysterious form of energy that permeates all of space, pushing it apart. Unlike gravity, which pulls matter together, dark energy exerts a repulsive force stretching the very fabric of the universe. It is not located in galaxies or stars, but in the emptiness between them, woven into the structure of space-time itself. Today, dark energy is thought to make up nearly 70% of the universe. That means most of reality, most of everything, is this unseen force. Yet we don't know what it is. It doesn't emit light or radiation. It doesn't clump like matter or follow the ordinary rules of energy we understand. It is, in every sense, the universe's most profound mystery, a presence we can measure but cannot describe. One possible explanation is that dark energy is the cosmological constant Einstein once introduced into his equations, a kind of inherent pressure built into the vacuum of space. Empty space, according to quantum theory, is not truly empty. It seethes with virtual particles that flicker in and out of existence, creating a subtle background energy. Perhaps this vacuum energy is what drives cosmic acceleration. But if so, the numbers don't add up. The predicted energy of the quantum vacuum is far greater, by a factor of 10 to the power of 120, than what we observe. A discrepancy so vast it's been called the worst theoretical prediction in physics. Others propose that dark energy could be dynamic, changing over time, a field rather than a constant, something that evolves as the universe grows. This idea, sometimes called quintessence, suggests dark energy might one day weaken, stop, or even reverse. If it strengthens instead, the universe could face a catastrophic end, a big rip, where galaxies, stars, and even atoms are torn apart by runaway expansion. Whatever its nature, dark energy determines the destiny of the cosmos. If it continues to push with its current strength, galaxies beyond our local group will drift out of sight, their light stretched into nothingness. The universe will grow vast and cold, every island of matter left alone in an endless dark sea. But if dark energy fades, gravity might one day take over again, pulling the universe back into itself, collapsing in a final blaze known as the Big Crunch. For now, we live in a delicate, fleeting moment. The balance point between light and silence, expansion and stillness. The galaxies we see today are the ones still close enough to share their light before they vanish forever beyond the accelerating horizon. Dark energy is the quiet breath of the cosmos, an invisible tide shaping eternity. We may not yet understand what it is, but its influence surrounds us, stretching space between galaxies even as we speak. It is the unseen pulse of the universe itself, gentle, relentless, and infinite. Between clusters of galaxies stretch unimaginable voids, cosmic deserts where nothing exists, not even stray atoms. They are the universe's quietest places. If the galaxies are the luminous cities of the cosmos, then the voids are the vast oceans of darkness that separate them. Immense regions spanning hundreds of millions of light years, nearly empty of matter. In these places, gravity has swept away almost everything, leaving only the faintest trace of hydrogen atoms adrift in the endless dark. The nearest of these cosmic voids begins just beyond our own galactic neighborhood, an expanse so empty that if our entire Milky Way floated within it, the nearest galaxy would lie beyond the reach of our most powerful telescopes. Astronomers first discovered these voids in the 1980 seconds while mapping the large-scale structure of the universe. What they found was astonishing. Galaxies were not randomly scattered, but arranged in intricate filaments and walls surrounding enormous bubble-like cavities. The cosmic web, they realized, was made as much of emptiness as of substance. These voids make up the majority of the universe's volume, more space between things than things themselves. Inside a cosmic void, the laws of physics remain the same, but their stage is almost empty. The gravitational pull of the surrounding galaxies pushes matter away, deepening the hollowness. There are no stars to light the darkness, no planets to orbit unseen suns. It is a silence so complete it defies imagination, a silence not of sound but of presence itself. Even light struggles there, crossing distances so vast that entire epochs pass before it reaches the other side. And yet, these voids are not truly nothing. Within them drift faint threads of dark matter, tenuous and unseen, forming the ghostly framework that connects everything. Occasionally, a lone galaxy can be found adrift within the emptiness, a cosmic castaway, surviving in solitude far from any neighbors. These void galaxies are among the most isolated structures in existence, evolving in near-perfect stillness, untouched by the collisions and turbulence that shape most of the cosmos. To stand in such a place, if one could, would be to experience the closest thing to absolute stillness the universe allows. There would be no up or down, no sound, no light from nearby stars. Space itself would stretch undisturbed in every direction, the faint cosmic microwave background whispering faintly through the dark. It would be the truest form of cosmic peace, a place beyond time's rush and gravity's grasp. But the voids are not useless or empty in a cosmic sense. They shape the universe's structure as much as the galaxies do. Their emptiness accentuates the filaments and clusters that surround them, giving the cosmos its great foam-like texture, matter, and light forming the thin walls of an enormous invisible lattice. Without the voids, there would be no contrast, no pattern, no structure. The universe would simply be a bland fog of matter, featureless and still. In their silence, the voids teach a quiet lesson that emptiness is as essential to existence as matter itself. Just as the spaces between notes give music its rhythm, the voids give the universe its form. They are the pauses between the galaxy's symphony, the quiet breath of the cosmos, vast, patient, and eternal. From here, the light we see was born just 380,000 years after the Big Bang. Beyond this sphere lies a realm we can never reach, a wall of cosmic silence. When we look as far as physics allows, when our telescopes gather the faintest photons that have crossed nearly 14 billion years of time, we arrive at a boundary, not the edge of space, but the edge of sight. It is a shimmering veil woven from the oldest light in existence. The cosmic microwave background, the faint afterglow of creation itself. Beyond it, the universe remains invisible, shrouded in its earliest darkness. This edge is not a physical wall, but a horizon, a limit defined by time, not distance. The light from that boundary began its journey when the universe was only a newborn, just emerging from its opaque infancy. Before that moment, the cosmos was a hot, dense plasma where light could not travel freely. Photons were trapped, scattered endlessly by free electrons, unable to escape. When the universe cooled and atoms formed, the fog lifted. Light broke free, and that light is what we see today when we look deep into the cosmic past. The edge of the observable universe lies about 46 billion light-years away in every direction. This might seem impossible. How can something be farther than 14 billion light-years old? The answer lies in the expansion of space itself. While light has been traveling toward us for 13.8 billion years, the fabric of space has stretched during that time, carrying distant galaxies even farther away. What we see at the edge is not how things are now, but how they were billions of years ago. An ancient portrait frozen in light. Beyond that edge, space continues. The universe doesn't end there. It simply extends into a realm we cannot observe. Light from those regions hasn't had enough time to reach us since the beginning of time. Those galaxies, if they exist, are receding faster than their light can ever travel, a cosmic horizon that defines the limit of our visible universe. Beyond it, there may be countless more galaxies, clusters, and voids, stretching on forever, unseen and unknowable. The James Webb Space Telescope peers as close to this edge as human technology allows. Its sensors capture the faint infrared glow from the first galaxies that formed just a few 100 million years after the Big Bang. Tiny, fragile beacons suspended near the edge of time. Each new discovery brings us closer to the cosmic dawn, to the threshold where light itself was born. And yet, no matter how advanced our instruments become, this boundary will remain. It is not something we can cross, nor something that recedes as we chase it. It is a cosmic event horizon, set by the speed of light and the expansion of space-time, an unbreakable law written into the geometry of reality. To gaze upon that distant light is to see the beginning of everything that ever was. To glimpse the universe as a child, still glowing with the warmth of creation. Beyond it lies silence, a vast invisible continuum that may stretch into infinity or curve back upon itself. We may never know. And perhaps that's part of the beauty. The edge of the observable universe is not a wall keeping us out. It is a mirror reflecting how far we have come. Every photon that reaches us from that horizon carries a message from the dawn of time, that we exist in the brief, brilliant middle between darkness and light. Though it sounds like an explosion, the Big Bang was not a blast in space, but the expansion of space itself, an everywhere-at-once event that created time and distance in a single breath. In the beginning, there was nowhere, because there was no space. There was no when, because time itself had not yet begun. The universe began not as something expanding into space, but as space expanding from itself, a sudden unfolding of reality from a state of incomprehensible density and heat. Every point in the cosmos once occupied the same boundless moment. And with that first expansion, time began to flow, distances began to form, and the laws of physics were born. We call this moment the Big Bang, though the name can be misleading. There was no sound, for sound needs air to travel through. There was no center, for every point was the center. The universe did not erupt into a pre-existing void. It was the void becoming something. Energy condensed into matter, particles collided and combined, giving rise to everything we now know. In that instant, creation was not just a process. It was the act of existence itself awakening. For the first fractions of a second, reality was a storm. Temperatures soared above 1,000,000,000,000 degrees. Particles flashed in and out of existence, annihilating and reforming in a dance of unimaginable violence. Then, in what scientists call cosmic inflation, the universe expanded faster than light, not because anything moved through space, but because space itself was stretching, carrying everything with it. In less than a heartbeat, the cosmos grew from smaller than an atom to larger than a galaxy, smooth and vast and ready to evolve. As it expanded, it cooled. In those first fleeting moments, matter and energy separated, and forces began to take shape. Gravity, electromagnetism, and the nuclear forces fell into balance. Quarks bound together to form protons and neutrons. Within minutes, the first atomic nuclei emerged, hydrogen and helium, the simplest elements. The blueprint of the universe was already written in that cosmic fire. For nearly 380,000 years, the young universe remained opaque, a dense plasma where light could not travel freely. Then, as it cooled further, atoms formed, and photons were finally released. That first light still travels through the cosmos today, stretched into the faint microwave glow that fills all of space. The cosmic background radiation, the afterglow of creation itself. It is the Big Bang's echo, still humming quietly in every direction, a whisper from the dawn of everything. When we study that ancient light, we're not just observing radiation, we're reading a memory. The slight ripples and temperature variations within it tell us how matter first clumped together, how galaxies were seeded, and how the universe came to take shape. In that faint glow, we can trace our origins, like fingerprints left by the birth of time. It's humbling to think that the atoms in your body were once part of that primordial fireball, that the light still moving through the sky tonight began its journey when time itself began ticking. The Big Bang was not just the start of space, it was the start of meaning, of cause and effect, of before and after. And though that moment is long past, its echo remains everywhere. Every star that burns, every planet that spins, every heartbeat and breath, all are reverberations of that first cosmic expansion, ripples spreading endlessly across eternity. The universe is still unfolding, still echoing that first breath of creation, as if the Big Bang never truly ended, it simply became the story we are living. On scales smaller than atoms, space itself trembles, a seething ocean of energy and uncertainty. The very fabric of reality bubbles with spontaneous creation and annihilation. To the naked eye, the universe appears smooth and still. Even through our most powerful telescopes, space seems vast, empty, and calm. But deep beneath that quiet lies a hidden turbulence. At the smallest possible scales, far beyond atoms, beyond quarks, beyond even the reach of our most advanced microscopes, space itself ceases to be smooth. It becomes frothy, unstable, unpredictable. This realm is called the Planck scale, and it is here that the very foundations of reality begin to blur. At this infinitesimal level, quantum mechanics rules with absolute authority. According to Heisenberg's uncertainty principle, energy and time can never be perfectly known at once. This means that even in the emptiest vacuum, energy can momentarily appear from nothing, creating pairs of particles and antiparticles that blink into existence and then annihilate each other almost instantly. This endless flickering of energy gives rise to what physicist John Wheeler poetically called quantum foam, the restless undercurrent of the universe. Imagine the surface of a calm ocean viewed from a great height. It looks perfectly smooth, but descend close enough, and you'd see the constant rippling of waves, eddies, and bubbles. Space itself behaves the same way. From afar, the universe seems continuous and orderly, but zoom in to the Planck scale, about 10 to the power of negative 35 meters, and space-time churns like boiling water. Gravity and quantum forces clash and merge in chaotic ways we can barely begin to describe. Here, the distinction between something and nothing dissolves. The vacuum of space is not truly empty. It teems with ephemeral energy. These virtual particles, though short-lived, can have measurable effects. They cause atoms to shift energy levels, alter the path of light, and even influence how gravity behaves on the smallest scales. In a sense, what we call nothingness is a kind of quantum storm, an invisible froth of existence, where creation and destruction are continuous and instantaneous. This quantum foam may be more than a curiosity. Many physicists believe it forms the true fabric of space-time itself, the microscopic scaffolding from which the universe is built. Every atom, every photon, every bit of matter and energy may rise from the fluctuations within this quantum sea. The foam connects the smallest scale of physics to the largest, linking the trembling chaos beneath reality to the smooth expansion of galaxies above. And within that connection lies one of science's greatest mysteries: how gravity fits into the quantum world. Einstein's theory of general relativity describes space-time as smooth and continuous, while quantum mechanics paints it as jittery and discrete. Somewhere in the foam, these two great theories must meet. The search for a theory of quantum gravity, the unification of the very large and the very small, may one day reveal how space-time itself emerges from this bubbling chaos. It's a humbling thought that the entire universe, from the birth of galaxies to the beating of your heart, might be built upon this invisible froth of energy. Even what seems solid and permanent is, at its core, an intricate vibration within the cosmic sea. Reality, it seems, is not made of stillness, but of motion. Beneath every atom, beneath every thought, the universe is still bubbling, still restless, still whispering its quiet song of creation and annihilation. The quantum foam is the breath beneath existence, the smallest waves in the infinite ocean of being. Some scientists believe our universe is one bubble among countless others, each with its own laws of physics, floating in a cosmic sea of infinite possibility. It sounds like science fiction, yet it arises naturally from our best theories of cosmology and quantum physics. The multiverse hypothesis suggests that what we call the universe might be only one small pocket of a far grander reality, a single bubble in an infinite cosmic ocean, where new universes are constantly being born. If true, the night sky we see is not the whole of creation, but merely one window among countless others, each glowing with its own version of existence. The idea begins with cosmic inflation, the rapid expansion that followed the Big Bang. Physicists believe that during those first fractions of a second, space didn't simply grow, it ballooned exponentially, doubling in size again and again in less than a heartbeat. Most versions of inflation theory suggest that this expansion never truly stopped. While our region of space cooled and slowed, inflation continued elsewhere, eternally spawning new bubble universes. Each bubble represents a new Big Bang, a new cosmos, potentially with different laws of physics and constants of nature. This endless process is known as eternal inflation, a cosmic fountain, forever creating new worlds. Inside each bubble, reality might unfold differently. Some universes could be barren, collapsing back into nothingness within moments of their creation. Others might last for eons but lack the right balance of forces to form stars or atoms. And perhaps, in a few rare cases, the conditions are just right, like ours, for galaxies, life and consciousness to arise. If the multiverse exists, then we live in one of the few universes capable of asking about it. But the concept stretches even deeper than cosmology. Quantum mechanics, too, hints at a multiverse of its own. In the many worlds interpretation, every quantum event that could happen does happen, branching reality into a near infinite number of possibilities. Every decision, every particle interaction, every fluctuation of energy creates new timelines, alternate universes, coexisting with our own, differing by the smallest of details or the greatest of outcomes. In one, you turn left instead of right. In another, the stars themselves evolve differently. These two ideas, cosmic and quantum multiverses, may be connected. Perhaps the quantum foam that underlies space-time spawns entire universes as easily as particles. Perhaps every bubble universe in the larger multiverse is itself a quantum fluctuation made real, a spark of possibility inflated into existence. And yet, for all its elegance, the multiverse remains beyond our direct reach. The regions beyond our cosmic horizon are expanding away faster than light. No signal, no telescope, no experiment can cross that gulf. Even if other universes exist, they remain forever isolated, sealed in their own space-time bubbles. We may never see them, but we might see evidence of their presence, faint imprints in the cosmic microwave background, subtle patterns in gravitational waves, or mathematical clues in the structure of fundamental laws. If the multiverse is real, it changes everything. It means that reality is not singular, but infinite. Every combination of matter, energy, and possibility exists somewhere. Somewhere, a universe expands backward in time. Somewhere, galaxies are made of antimatter. Somewhere, another you looks at another night sky, wondering the same thing. And perhaps, in the deepest sense, the multiverse is not a collection of separate worlds at all, but a single, infinite tapestry. Each universe a thread, each possibility a shimmer in the same boundless fabric of creation. Ours is only one story among endless others, but even one story, in a sea of infinity, is enough to make existence profound. Even the most radiant suns must die. Some collapse quietly into white dwarfs, others explode in spectacular supernovae, scattering their remains across the cosmos. Stars, like living things, have life cycles. They are born from clouds of gas and dust, burn through their fuel in brilliant splendor, and eventually meet an end shaped by their size and mass. Their deaths, though inevitable, are not tragedies, they are transformations. Through their endings, the universe renews itself. Every atom in your body was once forged in the heart of a dying star. The life of a star is a delicate balance between gravity and pressure. Gravity pulls inward, trying to collapse the star, while the heat and radiation from nuclear fusion push outward, keeping it stable. For millions or billions of years, this equilibrium holds. But when the star runs out of hydrogen, the fuel that powers its brilliance, gravity begins to win. What happens next depends on the star's size. Small and medium stars, like our Sun, end their lives gently. When the hydrogen in their cores is depleted, they begin to fuse helium, swelling into enormous red giants. Their outer layers puff outward, glowing softly as the core contracts. Eventually, those outer layers drift away, forming a delicate shell of glowing gas called a planetary nebula. What remains behind is a white dwarf, a dense, Earth-sized remnant that no longer burns but glows faintly from residual heat. Over trillions of years, it will cool and fade into darkness, becoming a cold black dwarf, invisible and silent. But for massive stars, the finale is far more dramatic. When they exhaust their fuel, their cores collapse catastrophically, triggering an explosion so powerful it briefly outshines entire galaxies. This is a supernova, one of the most violent events in the universe. In that blinding instant, new elements are created. Iron, gold, uranium, materials that did not exist before. The shockwave from the explosion blasts these elements into space, seeding nearby clouds of gas and dust with the building blocks of new stars, planets, and life. The universe's cycle of creation continues. Sometimes, the collapsed core of a massive star becomes a neutron star, a sphere only a few kilometers wide, yet heavier than the Sunday. A teaspoon of its material would weigh billions of tons. Spinning rapidly, it emits beams of radiation that sweep across the sky like lighthouse beams. These are pulsars, cosmic beacons that tick with the precision of atomic clocks, reminders of the stars that once were. And for the most massive of all stars, the collapse goes further still. Gravity crushes the core until not even light can escape, forming a black hole, a singularity hidden behind an event horizon. In death, these stars create the most mysterious objects in the universe, warping space-time itself and holding secrets about the nature of existence. The death of a star is not the end, but a beginning. From its ashes come new stars, new planets, new possibilities. The carbon in your cells, the calcium in your bones, the oxygen you breathe, all were born in the fiery deaths of ancient suns. You are, in the most literal sense, the the continuation of their story. One day, billions of years from now, our own sun will follow the same path, swelling into a red giant, shedding its outer layers, and leaving behind a white dwarf that will glow softly in the darkness. Long after Earth is gone, that remnant light will still shine, a faint echo of the star that once gave us life. In the quiet rhythm of stellar death, the universe reminds us that endings are never truly ends. They are transformations, the stars exhaling, the cosmos breathing, and creation finding new ways to begin again. Every atom in your body was forged inside a star. The calcium in your bones, the iron in your blood, all born from ancient stellar furnaces that lived and died long before Earth existed. In the earliest moments after the Big Bang, the universe was simple, too simple for complexity to exist. It was a hot, glowing sea of the lightest elements, mostly hydrogen and helium with just a trace of lithium. Everything heavier, the carbon in our cells, the oxygen in our lungs, the silicon beneath our feet, had yet to be created. The cosmos was a blank canvas, waiting for the stars to paint the elements of existence upon it. The first stars were the universe's great alchemists. In their cores, immense pressure and heat fused hydrogen atoms into helium, releasing radiant energy that balanced the crushing pull of gravity. But this was only the beginning. As these stars aged, their internal temperatures climbed, igniting new stages of fusion. Helium fused into carbon, carbon into oxygen, oxygen into silicon, and silicon into iron. Each step forged heavier and more complex elements, building the periodic table from the simplest ingredients in the cosmos. Yet, even the most powerful stars could only take this process so far. When fusion produced iron, the reactions no longer yielded energy. Instead, they consumed it. At that moment, the delicate balance between gravity and radiation collapsed. The star's core imploded, and the outer layers were blasted outward in a violent supernova, a cosmic explosion so intense it could outshine an entire galaxy. In that brief, blinding instant, temperatures soared to unimaginable extremes, and new elements were created in a flash: gold, silver, uranium, and all the heavy metals that make up planets and life itself. These newly forged atoms were flung into space, scattering like glitter into the darkness. Over millions of years, they mingled with interstellar gas and dust, enriching the galaxy with the raw materials of future worlds. When new stars were born, they inherited this enriched matter. Around them, planets formed, worlds made of the ashes of ancient suns. Our solar system was one of those descendants, built from the remnants of countless generations of stars that lived and died before it. Every rock on Earth, every drop of water, every breath of air is part of that story. The carbon that fuels your cells once burned in the heart of a dying star. The gold in your jewelry was born in a neutron-star collision, a cataclysmic merging of stellar corpses that released more energy than 1 billion supernovae combined. The oxygen in your lungs, the nitrogen in your DNA, the phosphorus that powers your brain, all are ancient, cosmic relics. You are quite literally the universe, made self-aware. This is what Carl Sagan meant when he said, "We are made of star stuff. It is not poetry, it is physics. The universe is not separate from us, it flows through us. The atoms that make up your body are billions of years old, forged in the fires of stars, scattered across the galaxy, and assembled into life by the gentle chemistry of time. And when our own sun reaches the end of its life, it too will return its elements to the cosmos, seeding the next generation of stars and planets. The cycle will continue, an eternal rhythm of creation, death, and rebirth, written in the language of starlight and matter. The next time you look up at the night sky, remember that you are looking at your own history. Every twinkle, every shimmer is a reflection of your atomic heritage. The stars do not just surround you, they are within you. Their light is your light. Their story is your story. Around newborn stars, dust and gas swirl into disks that clump and collide, forming planets, moons, and worlds still warm from creation. Every star begins its life inside a collapsing cloud of gas and dust. As gravity pulls the material inward, it spins faster and flattens into a glowing disk, a protoplanetary disk, a cosmic nursery filled with potential. At the center, the young star ignites, blazing to life. Around it, countless grains of rock and ice dance in delicate orbits, bathed in starlight. This swirling chaos is where worlds are born. At first, these particles are tiny, microscopic specks drifting in the stellar wind, but collisions are inevitable. Dust grains stick together through static electricity, forming pebbles, then boulders, then kilometer-wide planetesimals. Over time, gravity takes command. These growing bodies pull in more material, merging into protoplanets, the embryos of future worlds. Every collision shapes the system's destiny. Some bodies grow massive enough to clear their orbits, becoming planets. Others remain small, asteroids, comets, and moons, silent witnesses to the solar system's violent youth. The process is not gentle. Early planetary systems are chaotic and dangerous. Collisions between forming worlds release unimaginable energy. Oceans of molten rock churn beneath blazing skies. Moons are born from impact debris, as ours likely was when a Mars-sized body struck the early Earth. For millions of years, the newborn system glows with heat, its worlds still molten, their surfaces remade again and again by collisions. It is a cosmic forge, sculpting chaos into order. Eventually, as the system matures, the debris thins and the violence subsides. The inner regions cool, forming rocky planets where metals and silicates condense. Farther out, icy compounds like water, methane, and ammonia solidify, creating the cores of gas giants. These giants, with their immense gravity, capture thick envelopes of hydrogen and helium, becoming swollen worlds like Jupiter and Saturn. Beyond them, icy fragments remain in deep freeze, forming comets and dwarf planets, frozen relics from the dawn of creation. Around many stars, this process is unfolding even now. The James Webb Space Telescope and ALMA Observatory have captured breathtaking images of these dusty disks, with dark gaps carved by planets in the making. In some, we see the first hints of new worlds forming. Rings of dust illuminated by starlight, the soft glow of creation caught in mid-motion. Each one is a solar system in progress, a future set of worlds orbiting in harmony. Our own Earth was once part of such a swirling disk. 4.5 billion years ago, it emerged from the cosmic dust that circled the newborn Sunday. Over time, it cooled, oceans formed, and life began its improbable ascent. What began as stardust became consciousness gazing back at the stars. And this process is not rare, it's universal. Nearly every star in the night sky likely hosts planets of its own. Some may resemble Earth with blue oceans and drifting clouds. Others may be frozen or scorched, orbiting too close or too far from their stars. Yet each one represents a new possibility, a new chapter in the universe's story of creation. The birth of planets is the universe's quiet craftsmanship, a work of patience and persistence. It takes millions of years to turn dust into worlds, but the result is magnificent, places where oceans shimmer, mountains rise, and perhaps where life begins. From the ashes of ancient stars and the dust of forgotten nebulae, the cosmos sculpts beauty anew, reminding us that even in the coldness of space, creation never truly ends. Not too hot, not too cold, a narrow ribbon of space around a star where liquid water can exist. It is here that life has its best chance to awaken. Every star hosts a region where conditions are just right for liquid water, neither evaporated by scorching heat nor frozen by frigid cold. Astronomers call this the habitable zone, but it's more poetically known as the Goldilocks zone, a cosmic sweet spot where worlds might cradle oceans, clouds, and perhaps the fragile chemistry of life. Our own planet sits comfortably within this zone. Earth's distance from the sun allows water to flow, rain, and cycle between ocean and sky. If we were a little closer, our atmosphere might have boiled away like Venus. A little farther, and Earth could have become an icy wasteland like Mars. But here, in this delicate balance, our world found equilibrium, and life found a foothold. The Goldilocks zone is different for every star. Around hot blue giants, it lies far from the stellar furnace, so distant that planets orbiting there would take decades to complete a single year. Around smaller, cooler stars, the habitable zone is much closer, sometimes so tight that a planet's year lasts only a few days. These worlds, orbiting red dwarfs, are bathed in dim, crimson light. Some may be tidally locked, with one side eternally facing their star, while the other lies in perpetual night. Yet even there, along the twilight boundary between light and dark, life could conceivably thrive. The ingredients of habitability go beyond distance. A planet must have the right atmosphere to trap heat and maintain pressure for liquid water. Too much, and it becomes a runaway greenhouse. It must also be geologically active, cycling carbon and minerals through volcanoes, oceans, and continents. The magnetic field must shield it from stellar radiation. Life, it seems, is not born from perfection, but from balance. Across the galaxy, telescopes like Kepler and TESS have discovered thousands of exoplanets, many orbiting within their stars' Goldilocks zones. Some are rocky and Earth-sized, others are ocean worlds, their surfaces entirely covered in water. Each discovery widens the horizon of possibility. Statistically, there may be billions of habitable planets in our galaxy alone. Billions of worlds where the conditions for life are met. Whether any of them have taken that next miraculous step, life itself, is a question that still haunts our collective imagination. And yet, even on Earth, life has proven adaptable beyond imagination. It thrives in boiling hydrothermal vents, beneath Antarctic ice, and deep within radioactive rocks. If life can exist in such extremes here, perhaps it can exist elsewhere, in places we once deemed inhospitable. The Goldilocks zone, then, might be broader than we once thought. Life may not need perfect comfort. It only needs a chance. To ponder the Goldilocks zone is to reflect on our own improbable fortune. Out of all the places the universe could have placed us, we exist in the thin, shimmering band where life is possible. We orbit a stable star with the right warmth, the right atmosphere, the right timing. The odds seem impossibly small. Yet here we are, thinking, dreaming, reaching toward the stars that might harbour others like us. Perhaps somewhere out there, on another pale blue world bathed in golden light, other beings look up at their sky, wondering the same thing, if they too are alone, or if life, once kindled, spreads wherever the universe allows. From the smallest pebble to the mightiest black hole, gravity orchestrates the motion of everything, binding time, space and matter into a single cosmic rhythm. It is the universe's most ancient force, the quiet conductor of all motion. Gravity doesn't roar like thunder or blaze like fire, it whispers. Yet, through its steady pull, it has shaped every star, planet and galaxy in existence. It gathers dust into worlds, stirs gas into stars, and sculpts galaxies into spirals that drift through the void like celestial symphonies frozen in time. Every movement in the cosmos is a note in gravity's grand composition. The Earth orbits the Sun in perfect cadence, the Moon pirouettes around Earth, and entire galaxies waltz around one another across billions of light years. From the falling of an apple to the dance of galaxies, gravity is the same, gentle, relentless, universal. It is both invisible and absolute, weaving motion into harmony and chaos into structure. For centuries, gravity's nature was a mystery. Isaac Newton first gave it shape, describing it as an invisible thread that pulls all matter together across distance. To him, it was an action at a distance, instant and eternal. But centuries later, Albert Einstein revealed a deeper truth. Gravity is not a force pulling objects through space. It is space itself, bending and curving under the weight of matter and energy. Planets orbit stars not because they're tugged by an unseen hand, but because stars curve the fabric of space-time, creating pathways that planets naturally follow. Imagine placing a heavy ball on a stretched sheet of fabric. It creates a dimple, and smaller marbles roll toward it. That's how the universe behaves, except in 3 dimensions, and the marbles never stop moving. This bending of space-time is what keeps the moon in orbit, what guides the light from distant galaxies, and what allows black holes to trap even photons within their grasp. And yet, gravity is paradoxical. It is the weakest of all fundamental forces, trillions of times weaker than electromagnetism, and yet, on the grand scale, it dominates everything. It holds galaxies together, governs the structure of the universe, and even slows the passage of time itself. Clocks tick more slowly in strong gravitational fields. Space and time stretch and warp under its influence. In the presence of great mass, even reality bends. Sometimes, when massive objects collide, like 2 black holes or neutron stars, gravity sends ripples through space-time itself. These gravitational waves are the faintest echoes of cosmic events, traveling outward at the speed of light. When scientists first detected them in 2015, it was as though the universe had finally been heard humming its own melody. For the first time, we were not just looking at the cosmos, but listening to it. Gravity is more than a force. It is the music of existence. It gives rhythm to orbits, harmony to galaxies, and structure to time. Without it, there would be no stars, no worlds, no us, only formless motion adrift in nothingness. And yet, gravity is also destiny. It will one day decide how the universe ends, whether it continues expanding forever or collapses back into itself in a cosmic crescendo. Until then, every movement, every heartbeat, every orbit and fall plays its part in the same eternal song. To live within this symphony is to be part of the universe's most beautiful truth, that everything, from the smallest grain of dust to the grandest galaxy cluster, moves together in harmony, bound by the silent music of gravity. Over billions of years, galaxies collide and merge, weaving new constellations and triggering bursts of star formation, cosmic rebirth through destruction. From the outside, the universe might appear eternal and unchanging, its galaxies drifting in quiet majesty through infinite space. But the truth is far more dynamic. Every galaxy, including our own, is part of a slow, intricate dance that spans billions of years, a gravitational choreography that will ultimately decide their destinies. They attract, collide, merge, and reshape one another in an endless cycle of creation and transformation. When 2 galaxies draw near, gravity begins to weave their fates together. At first, the stars within them remain largely untouched. The vast distances between stars mean that direct collisions are rare, but their shapes begin to distort. Tidal forces stretch their arms into luminous bridges and tails, like ribbons of light pulled across the dark. Clouds of gas collide, compress, and ignite, triggering starbursts, intense periods of star formation that light up the merging galaxies with newborn suns. What might seem like destruction is, in fact, renewal. The chaos of a galactic collision creates the conditions for new generations of stars to form, seeding the next chapter of cosmic evolution. Over millions of years, the colliding galaxies gradually merge into a single larger one, their stars settling into new orbits. Some merge into graceful elliptical galaxies, smooth, featureless spheres of ancient light. Others become warped, irregular, or spiral anew. Each merger leaves behind a celestial fingerprint, a mark of the universe's constant recreation. Our own Milky Way is not exempt from this fate. In roughly 4 billion years, it will collide with the Andromeda Galaxy, our nearest galactic neighbour. The two are already on a slow-motion collision course, closing the distance between them at more than 100 kilometers per second. When they finally meet, they will not crash like solid objects, but rather pass through one another, their stars continuing unscathed while their gases collide and compress. For a time, the night sky will be transformed. A spectacle of unimaginable beauty, with the spirals of Andromeda stretching across the heavens like ghostly wings. Eventually, after several passes, the 2 galaxies will merge completely, forming a new, massive, elliptical galaxy. Astronomers have nicknamed Milkomeda. Our Sun, if it still burns, will find itself in a new cosmic home, orbiting a different center in a vastly changed sky. It is a reminder that even the grandest structures in the universe are not permanent. They are part of an ongoing story written in light and gravity. Beyond the local universe, this cycle plays out countless times. In galactic clusters, collisions are frequent, shaping the evolution of entire cosmic cities. The largest galaxies in the universe, the giant ellipticals at cluster centers, are built from hundreds of mergers, each one the ghost of a galaxy long gone. In this way, the cosmos grows old gracefully, recycling its matter, reusing its light. But there will come a time when the great mergers end. As dark energy drives the universe's expansion faster and faster, distant galaxies will drift beyond reach. Collisions will cease, and each galactic island will remain forever isolated, surrounded by deepening darkness. Still, for now, the dance continues, a slow, magnificent ballet of matter and time. The fate of galaxies is not destruction, but transformation. In every collision, the universe reminds us that endings are never absolute. They are simply new beginnings, fresh notes in the endless cosmic symphony that began with the first light and will echo until the last star fades. In 4 billion years, our galaxy will collide with Andromeda. The night sky will erupt in rivers of stars, an awe-inspiring slow dance that lasts billions of years. Even now, the Andromeda Galaxy, our closest spiral neighbor, is hurtling toward us at a breathtaking speed of about 110 kilometers per second. Though that sounds unimaginably fast, the scale of the cosmos makes it a graceful, almost tender approach. Across the vast gulf of 2.5 million light-years, gravity has already bound our galaxies in a cosmic embrace that neither can escape. Their fates are sealed, written in the slow rhythm of the stars. When Andromeda first becomes visible to the naked eye as more than a faint smudge of light, it will grow brighter and larger with each passing eon. Future beings on Earth, if any remain, will watch in wonder as its spiral arms stretch across the sky. It will dominate the heavens, shining brighter than the moon, its billions of suns merging into a glowing bridge of light. Yet, what we'll witness is not destruction, but an elegant ballet, a merging that unfolds so slowly that, for generations, the sky will seem to change only subtly, like the turning of a great cosmic tide. When the two galaxies finally meet, their graceful spirals will distort under the force of gravity. Vast streams of stars will be flung outward, forming glowing arcs that span light-years across. Clouds of gas will collide, compressing into new pockets of intense star formation. For a brief moment in cosmic time, perhaps a few 100 million years, the combined galaxies will shine with renewed brilliance, birthing clusters of newborn suns amid the chaos. Despite the drama, most stars will never collide. The distances between them are so immense that they will simply weave past one another, their paths subtly bent by gravity. Our Sun, too, will survive the merger, though its orbit will change. Astronomers predict it may be flung outward into a vast new trajectory, orbiting the heart of the newly formed galaxy from afar. By then, Earth itself will likely be uninhabitable, scorched by the aging sun. But the atoms that once formed our world may drift on, carried within the luminous waves of this grand collision. After several close encounters, the Milky Way and Andromeda will merge completely, their spiral shapes dissolving into a single massive elliptical galaxy, a new cosmic entity sometimes called Milkomeda. Its core will blaze with the combined power of two supermassive black holes, spiraling toward one another, releasing ripples of gravitational waves that echo across space-time. Eventually, they will merge as well, forming a single titanic black hole millions of times the Sun's mass. In the end, the night sky will be forever changed. From within this new galaxy, the heavens will glow with tens of trillions of stars, their light forming a radiant ocean stretching in every direction. Yet beyond that brilliance, darkness will reign. The accelerating expansion of the universe will have carried distant galaxies so far away that their light can no longer reach us. The cosmos will grow quieter, more isolated. And so, what begins as a collision will end as creation, a transformation, not an end. The Milky Way and Andromeda, two spirals long separated by light years, will become one, an eternal testament to the beauty of cosmic evolution. It is a reminder that even destruction in the universe is a form of artistry, a renewal written in gravity's hand. In the silence of deep time, galaxies dance not to end, but to begin again, merging their light into something greater than either could be alone. Far into the future, new stars will cease to form. The universe will grow dark and cold, lit only by the dying embers of ancient suns. The cosmos, once ablaze with light, will slowly dim. Star formation, once a constant hum of creation, will quiet as the galaxies exhaust their fuel. The great molecular clouds that once birthed new suns will dissipate, scattered by radiation and time. One by one, the nurseries of the universe will go dark, their potential spent. The universe will enter what astronomers call the degenerate era, when the last flickers of starlight fade into the long night. For now, galaxies are vibrant with starbirth. Gas and dust swirl in brilliant nebulae, gravity-forging stars that illuminate their cosmic cradles. But this balance cannot last forever. Every star burns hydrogen into helium, and over billions of years, those reserves dwindle. Eventually, there will be no fresh material left to feed the furnaces of creation. The galaxies will age and fade like glowing coals, cooling into stillness. The last stars to shine will not be large or bright. They will be red dwarfs. Small, steady suns that burn their fuel with astonishing thrift. Some may live for trillions of years, far longer than the universe's current age. Around them may orbit the final havens of warmth, planets bathed in dim crimson light. If life still exists then, it will huddle close to the fading glow of these ancient embers, whispering against the encroaching dark. When even those red dwarfs exhaust their fuel, they will cool and shrink into white dwarfs, their radiance fading to invisibility. Over unimaginable spans of time, so long that entire galaxies will drift apart, their light will dim to nothing. They will become black dwarfs, dead remnants of stars, glowing faintly with the last traces of thermal memory. The sky, once filled with billions of suns, will be almost completely dark. Occasionally, two dead stars may collide, flaring briefly to life, a single spark against an infinite night. These rare encounters will be the last acts of cosmic brilliance, brief reminders of what once was. The universe will no longer shimmer with starlight, but will glow faintly in the infrared, the dim heat of forgotten worlds. Even the great galaxies will change. Without new stars to replace the old, they will fade into ghostly shadows of their former selves. The spiral arms will unravel. Black holes will dominate the centers. Over quadrillions of years, gravity will scatter their contents across the dark until only isolated stars remain, each drifting alone through an expanding void. Time will stretch beyond comprehension. Trillions upon trillions of years will pass. The black dwarfs will cool to near absolute zero. Brown dwarfs, failed stars, will freeze entirely. Planets will fall silent, their surfaces coated in eternal frost. The last flickers of light will come from the slow decay of matter itself, from particles unraveling in the silence of deep time. And yet, there is poetry in this ending. The universe began in a blaze of unimaginable heat and light, and it will end in stillness and peace. No sound, no warmth, no motion, just the faint hum of space-time, vast and eternal. The last stars will not rage against the dying of the light. They will simply fade, their warmth dissolving into the infinite calm. The cosmos will sleep, wrapped in darkness, dreaming perhaps of another beginning. For even in its quietest hour, the universe is never truly dead. It is simply waiting, resting between symphonies, the embers of creation still glowing faintly beneath the ashes of infinity. When the last light fades, black holes will dominate, a silent empire of gravity slowly evaporating into nothing through Hawking radiation. In the distant future, after the final stars have gone dark and the galaxies have dissolved into silence, only the universe's most enigmatic objects will remain: black holes. These are the ultimate survivors of cosmic time, remnants of massive stars and the cores of ancient galaxies, bound together by gravity so intense that not even light can escape. They are the keepers of the universe's final secrets, watching over the long twilight of creation. Black holes were once the hidden hearts of galaxies, devouring stars and gas, shaping the rhythm of cosmic evolution. But in the coming ages, as matter grows scarce and energy fades, they will become the rulers of a dark, empty universe. Around them, no light will shine. The last remnants of matter, stray atoms, cold planets, and drifting debris, will spiral inward, consumed by the inescapable pull of their event horizons. Yet even black holes are not eternal. Though they seem to represent permanence, Stephen Hawking's great insight revealed that they too can die. According to Hawking radiation, black holes slowly lose mass over time as quantum effects near the event horizon cause particles to escape. This process is unimaginably slow for large black holes. It could take 10 to the power of 64 years or more for one the size of a star to evaporate completely. But in a universe where time stretches endlessly, even the slowest processes become inevitable. As eons pass, black holes will feed less and less. The galaxies that once nourished them will long since have dispersed. One by one, the supermassive black holes at the centers of ancient galaxies will stop growing and begin to shrink. Over quadrillions of years, they will emit faint streams of radiation, soft, ghostly whispers of energy leaking into the void. The largest of them, those with billions of solar masses, may take up to 10 to the power of 100 years to fade. But fade they will. During this black hole era, gravity will be the universe's last architect. Stars are gone, but black holes remain as silent wells in space-time, curving reality itself. Around them, the laws of physics continue to operate in slow motion, as if the universe is taking its final, deliberate breaths. Time itself stretches toward infinity, drawn out by the immense gravity that bends both space and duration. Eventually, the smallest black holes will vanish first, releasing their final bursts of radiation, tiny flashes of light in a universe otherwise devoid of warmth. These explosions, brief yet brilliant, will mark the last luminous events in cosmic history. The largest black holes will take far longer to die, but they too will evaporate, their event horizons shrinking until they wink out of existence, leaving only ripples of energy in their wake. When the last black hole dissolves, the universe will be left in near-perfect darkness. Space will continue to expand, carrying the faint remnants of energy farther and farther apart until even radiation itself becomes cold and diffuse. This will be the true end of time as we understand it, a cosmos emptied of structure, where the concepts of before and after lose all meaning. And yet, there is quiet beauty in this thought. The black holes, born from the deaths of stars, will have been the universe's final artists, sculpting space-time, preserving the memory of matter, and finally releasing it back to the void. In their slow evaporation, the last remnants of existence will return to the quantum sea from which everything once arose. The universe began with a flash of light and ends with a whisper of gravity, a slow, gentle sigh as the last black holes fade into nothingness. The empire of gravity will fall, and the cosmos will rest, empty but complete. Eventually, even black holes will vanish, and the universe will reach thermodynamic equilibrium, a quiet sea of cold, thin energy where nothing stirs. This is the final movement in the cosmic symphony, the slow fade into silence. After countless trillions of years, after the last black hole has evaporated and the final flicker of light has dissolved into the void, the universe will enter its stillest state. No stars will burn, no galaxies will form, no motion will remain unspent. The cosmos will have reached what physicists call the heat death, a condition of perfect balance where energy is spread so evenly that nothing more can happen. In the beginning, the universe was far from equilibrium. Energy blazed, matter formed, and temperature gradients drove creation. From those imbalances came stars, planets, and life itself, pockets of order born from chaos. But entropy, the universal measure of disorder, always increases. It is nature's quiet arrow of time, moving everything toward evenness. Each burning star, each collision, each thought adds a little more entropy to the cosmic ledger. Slowly, imperceptibly, the universe evens itself out. As expansion continues, galaxies drift farther apart. Their light stretches into longer and longer wavelengths, fading into the infrared, then into radio waves, until they are indistinguishable from the background hum of space. The few remaining atoms, scattered across the expanding void, grow colder as the temperature of the cosmos approaches absolute zero, a mere whisper above nothingness. Time still flows, but with no energy differences left, nothing changes. The universe becomes an eternal, featureless sea. At this stage, even matter itself may decay. Protons, the building blocks of atoms, might eventually disintegrate into radiation, leaving behind a universe composed only of the faintest quantum remnants. Space, once vibrant and structured, will stretch endlessly, filled only with a sparse mist of low-energy photons and neutrinos. Darkness will not merely dominate, it will be absolute. Yet this darkness is not sudden. It comes gradually, like the slow dimming of a fire that has burned for too long. Long before the final silence, there will be epochs where the universe seems almost empty, where entire regions of space lie untouched for trillions of years. Even the faint glow of dying black holes will one day seem like brilliant beacons compared to the cold eternity that follows. Time, by then, will lose meaning. Without change, there can be no before or after. The laws of thermodynamics dictate that entropy must always increase, but once it reaches its maximum, the universe becomes timeless, a frozen eternity where motion ceases and all potential has been spent. This is not an explosion nor a collapse, but a dissolution, existence diffusing into evenness. And yet, there is a haunting beauty in this ending. The universe began in perfect unity, a singularity, and after eons of evolution, it returns to a kind of stillness, not through destruction but through balance. The great drama of existence, stars, galaxies, life, thought, was possible only because the universe began in imbalance. The heat death is simply the restoration of that symmetry. We are fortunate to exist in the brief, radiant middle of the story, between the fire and the silence. Every star in the sky, every warm sunrise, every flicker of thought in the human mind is a rebellion against entropy, a spark of order in an entropic sea. But even as the universe cools, the memory of those sparks will remain written into its fabric, diffused among the faint radiation that outlives all else. When the final photon drifts endlessly through infinite space, the story of the cosmos will be complete. No more stars will rise, no more galaxies will turn, no more dreams will form, but in the silence that follows, the universe will at last find peace. The great fire will have burned itself to ash, and all that remains will be stillness, the eternal calm after the long, luminous song of time. In that final era, time itself loses purpose. Without change, there can be no before or after. The universe becomes an eternal pause. Time has always been the silent current beneath existence, steady, invisible, and relentless. It flows forward, giving shape to motion, life, and memory. But time, at its core, is not a thing in itself. It is a relationship between events. It measures change, the turning of planets, the beating of hearts, the decay of atoms. When there is no change, time ceases to matter. In the farthest reaches of the universe's future, when all movement has stopped and all energy has been evenly spent, time will lose its meaning altogether. In the heat death of the cosmos, every process that could ever occur will have already happened. No star will burn, no particle will collide, no molecule will vibrate. The temperature of the universe will approach absolute zero, and everything will exist in a state of perfect equilibrium, without contrasts, Without heat and cold, light and dark, motion and stillness, there will be no markers by which to measure the passage of time. The arrow of time, born from entropy, will have nowhere left to point. It's strange to imagine a universe without time. For us, time is the medium of experience, the very structure of thought. But on the deepest level, it is a byproduct of change. When physicists describe time in a static, unchanging universe, they find it collapses into a mere coordinate, an axis without motion. The future no longer unfolds, it simply is. In this final stillness, the universe becomes less a story and more a frozen painting, an eternal tableau where nothing happens because everything has already happened. Even now, we glimpse hints of this timelessness in the laws of physics. At the quantum level, certain equations make no distinction between past and future. To the universe, time may be an illusion, a local phenomenon that arises only where energy and matter interact, only where things evolve. When those interactions cease, the illusion dissolves. The cosmos remains, vast and unchanging, but the clock that once ticked within it stops forever. And yet, perhaps it is wrong to think of this as an ending. If there is no time, there can be no after. The universe simply is, an eternal state of balance, beyond decay or renewal. In that sense, the final epoch is not a death but a transformation. The cosmos will have achieved absolute stillness, a perfection so complete that even the concept of movement becomes meaningless. To stand, if one could, in that ultimate silence would be to exist outside of time itself. To witness eternity not as duration, but as presence. No ticking of moments, no unfolding of cause and effect, only the infinite seamless now. It is a haunting thought, yet somehow peaceful. The same universe that once roared with light, gravity, and life will end in complete serenity. Time, the restless river that carried everything forward, will finally settle into a boundless, unbroken sea. There will be no more beginnings, no more endings, only existence, quiet and complete. In that eternal pause, the universe will rest, not gone, not dead, but still. It will be the silence after the final note, the breath between creation and whatever may come next. Some theories suggest that from this stillness, fluctuations could trigger new big bangs, new universes blossoming from the ashes of the old. Even in the quietest void, the universe never truly sleeps. Beneath the stillness of ultimate entropy, beneath the long silence of the heat death, quantum mechanics still hums faintly, a whisper from the fabric of existence itself. The so-called nothing that fills empty space is not truly empty. It seethes, ever so slightly, with quantum potential, tiny fluctuations of energy that arise and vanish in an instant. And from such trembling could, perhaps, come everything once again. Physicists have long known that quantum fields are never at absolute rest. Even when the universe is frozen and devoid of matter, space itself retains a baseline energy known as the vacuum energy. This restless hum means that, given infinite time, a random fluctuation could become large enough to ignite a new expansion, a new Big Bang. In this way, the end of one universe could be the beginning of another, a cosmic heartbeat beating once every eternity. In this vision, the cosmos is not a single story with a clear beginning and end, but an infinite cycle of rebirth. Each universe begins in fire, expands, evolves, cools, and fades into silence, only for the quiet vacuum to shudder once more, giving birth to a new burst of light and time. These new universes might follow different physical laws, different constants, different dimensions. Some might collapse instantly, others might grow vast and long-lived, perhaps harboring galaxies and life of their own. Each Big Bang becomes a spark in an endless sea of creation. This idea, often called the quantum bounce or cosmic inflationary multiverse, is not proven, but it offers an elegant symmetry to existence. In the same way that dying stars seed new generations of worlds, perhaps entire universes give rise to others. Creation and destruction would not be opposites, but partners in an eternal dance. From chaos, order. From silence, sound. From nothing, everything. Some physicists imagine that our own universe may have been born from such a fluctuation in a previous cosmos. If true, the faint background radiation that fills our sky could be the echo of another universe's final sigh, a cosmic memory carried forward into our beginning. Others propose that black holes might serve as gateways, each collapse spawning a new universe within, its own Big Bang blooming beyond the event horizon. In this way, creation may be nested, recursive, universes within universes, each one a reflection of the last. And so, even as the universe approaches its apparent end, quantum physics leaves a back door open. The same uncertainty that governs the flicker of subatomic particles could, in time, breathe life into infinity once more. Reality, it seems, is unwilling to rest completely. It is comforting, perhaps, to imagine that the story never truly ends, that the cosmos itself has a kind of immortality, endlessly reinventing itself from its own ruins. Each universe, in turn, might contain others, branching endlessly like the roots of an infinite tree. In that vision, the silence after the heat death is not final, it is a pause between verses. The cosmos inhales, empties itself, and waits for the next spark. And then, somewhere in the endless dark, a quantum tremor stirs, energy coalesces, light returns, and time begins to flow again. The cycle starts anew, a new dawn, a new universe, a new chance for stars, for life, for wonder. From nothingness, being, from death, creation, the eternal rebirth of the cosmos, an infinite story written in the language of possibility. What if time runs backward somewhere beyond our horizon? A twin universe expanding in reverse, where entropy decreases instead of grows. It's a question that shimmers at the edge of physics and philosophy, one that invites us to peer into the deep symmetry of existence itself. Our universe, as we experience it, flows relentlessly forward. Entropy rises, stars burn out, order dissolves into chaos. But what if, on the other side of the Big Bang, or somewhere hidden beyond our cosmic horizon, another universe exists, one where time's arrow points the opposite way? This idea, known as the mirror universe hypothesis, springs from the equations of physics themselves. At their core, most of the fundamental laws of nature are time-symmetric. They work just as well backward as they do forward. If you were to reverse the direction of time in almost any physical equation, the math would still make sense. This raises an extraordinary possibility. Perhaps the Big Bang created two universes, not one. Ours, where time flows forward and entropy increases, and another, where time flows backward and entropy decreases, a perfect mirror image, expanding in the opposite temporal direction. To the inhabitants of that mirror cosmos, if such beings could exist, time would seem to move forward just as it does for us. They would live, think, and evolve, experiencing their own sense of past and future. But from our perspective, their universe would be running in reverse, like a film rewinding. Our deaths might align with their beginnings, our heat death with their Big Bang. Together, the two would form a single symmetric whole, a cosmos balanced across the axis of time. Some physicists, including Sean Carroll and Julian Barber, have speculated that this time reversal symmetry could be built into the very nature of the Big Bang. The singularity at the beginning of time may have been a point of perfect order, from which two arrows of time emerged, one moving forward, one backward. Each side would see itself as expanding and aging, unaware of its twin across the timeless divide. This concept also offers a tantalizing solution to one of physics' greatest mysteries. Why did the universe begin in such an extraordinarily low entropy state? If our cosmos is only half of a greater whole, then the total entropy of the meta-universe could still be balanced, perfectly symmetric. What we call the beginning may simply be the midpoint of something larger, an eternal mirror reflecting existence through time. And if this mirror universe exists, it might not be confined to speculation. Subtle imprints could remain in the cosmic microwave background, tiny asymmetries or temperature fluctuations that hint at an unseen counterpart on the other side. Some cosmologists even propose that certain dark matter particles could be mirror matter, passing invisibly between the two realms, ghostly reminders of the symmetry that binds them. It is strange, yet deeply poetic, to think that our universe's destiny might be another's dawn, that while we march towards stillness, another cosmos awakens in reverse, a reflection moving away from us, not through space, but through time. In that symmetry lies a kind of cosmic grace. For every death, a birth. For every end, a beginning. Two universes expanding back to back, forever mirroring one another in the grand symmetry of time. Perhaps then, the universe's greatest secret is not its vastness, but its balance. We are one half of a timeless whole, the echo of another reality where time's river flows the other way. And maybe, in that mirrored dawn, another sky rises, one that reflects ours perfectly, though we will never meet its gaze. Perhaps the edge of the universe is not a border at all, but a curve, a loop so vast that travelling far enough would bring you back to where you began. When we imagine the universe, it's tempting to think of it as a great sphere expanding into something larger, a cosmic balloon swelling into the void. But there is no outside of the universe, no wall, no edge, no place beyond. Space itself is not expanding into anything. It is the very fabric of reality stretching, carrying galaxies apart like dots on the surface of a rising tide. And so, the edge we seek is not a frontier we can cross, but an illusion born of perspective. Modern cosmology tells us that the universe is finite but unbounded, a shape that loops back on itself. Just as a traveller walking endlessly around Earth would never find a cliff at its end, one journeying far enough through the cosmos might, in theory, return to their starting point without ever encountering an edge. The universe may curve in on itself through higher dimensions, like the surface of a vast four-dimensional sphere. We, trapped within its fabric, perceive only its surface, our view limited to what light has had time to reach us. This curvature is subtle, almost imperceptible. On scales smaller than billions of light years, the universe appears flat, its geometry nearly perfect. But even a minute degree of curvature could mean that space eventually folds back upon itself. Light, travelling endlessly through such a cosmos, could circle around, creating ghostly echoes of galaxies, distant reflections of our own. Some astronomers even search the cosmic microwave background for repeating patterns, hoping to glimpse this cosmic mirroring, a fingerprint of a curved universe. If true, this means the universe has no true edge, only continuity. It has no center, no outside, and no boundary. It is a self-contained totality, infinite not in size, but in connection. Everywhere is equally the center. Every direction stretches endlessly, looping back through itself. To ask what's beyond the universe is to ask what's north of the North Pole. The question dissolves under its own logic. And yet, this concept of a universe that bends back upon itself is not just mathematical elegance, it carries a quiet existential beauty. It suggests that everything in the cosmos is linked, that the journey outward is also a journey inward. In such a universe, the explorer who travels to the farthest reaches of existence is not leaving home, but returning to it by another path. The cosmos becomes both infinite and intimate, a grand circle of being. This idea resonates deeply with ancient philosophy. Many cultures once imagined the universe as a great cycle, eternally folding back upon itself, birth and death, creation and destruction, expansion and return. Modern physics, with all its equations and data, seems to whisper the same truth, that reality might be round in ways we can barely comprehend. So, when we speak of the edge of the universe, perhaps what we really mean is the edge of our understanding. Beyond every horizon we chase, there is always another. And maybe, just maybe, the end of the universe is not a boundary to be crossed, but a revelation to be understood, that in the vastness of existence, there are no true endings, only curves, only returns. only the infinite circle of being, looping forever through space and time. Every atom in your body contains empty space, fields and particles dancing in miniature universes of their own. You are the cosmos observing itself. When you touch your hand to your chest, you are not touching something solid, but a symphony of energy, tiny particles held together by invisible forces, spinning in patterns that echo the structure of galaxies. Within every cell, within every atom, the vastness of the universe is reflected in miniature. At first glance, matter seems tangible, but if you peer deeper, you find that almost all of it is empty space. The nucleus of an atom is unimaginably small, and the electrons that orbit it are even smaller, their paths smeared into probability clouds rather than defined lines. If an atom were the size of a cathedral, its nucleus would be smaller than a grain of dust floating in the air, and the rest, everything else, would be void. Yet, within that emptiness, the universe hums with energy. According to quantum field theory, every particle, every electron, proton, and photon is a ripple in an underlying field that extends through all of space. You are, quite literally, made of waves, vibrations of energy interacting in a delicate balance. The same fields that exist inside you stretch endlessly across the cosmos, connecting you to every star, every planet, every mote of dust suspended in the galactic dark. There is no true boundary between you and everything else. You are a temporary pattern in an infinite sea of energy, a localized expression of the universe itself. And within you, the same principles that govern stars and galaxies play out in miniature. Nuclear fusion and decay, electromagnetic attraction, gravitational equilibrium. These aren't just cosmic phenomena, they're the same laws that bind the atoms of your body together. The iron in your blood came from the death of stars. The calcium in your bones was born in ancient supernovae. The carbon in your cells once drifted through interstellar space as dust, before finding its way into the cradle of Earth. You are, in every measurable way, a child of starlight. But beyond science lies wonder. The universe has, through billions of years of unfolding complexity, become aware of itself, through you. The same matter that once burned in stellar cores now thinks, feels, and dreams. The atoms that once drifted through the emptiness between stars now look up and ask where they came from. You are not an observer of the universe. You are a participant in it, a fleeting expression of its infinite creativity. When you breathe, the oxygen entering your lungs was forged in ancient suns. When you think, your neurons fire using electrical currents born from cosmic fields that have existed since the dawn of time. Every heartbeat, every thought, every flicker of awareness is the universe reflecting upon its own existence. And though your form will one day fade, the matter that makes you will not. Your atoms will scatter and reform, joining oceans, clouds, or perhaps even the birth of new stars. In this way, nothing is ever truly lost, only transformed. To realize this is to feel both small and infinite. You are a momentary arrangement of stardust, a flicker in the cosmic dream. Yet within that flicker lies everything. The same laws that govern galaxies, the same beauty that lights the heavens. You are the universe condensed into consciousness, the cosmos made self-aware, a fragment of infinity looking back at itself with wonder. All of human history, all of life, has unfolded in a blink of cosmic time. Yet, in that blink, the universe became aware of itself through our eyes. If the history of the universe were condensed into a single year, the Big Bang would erupt at midnight on January 1st, galaxies would form by March, and our sun would be born around September. Life on Earth would not appear until December, and all of recorded human history, all of civilization, art, and memory would occur in the final seconds before midnight on December 31st. That is how brief our story truly is, a heartbeat in eternity, a flicker of consciousness against an endless dark. It's humbling to remember that everything we know, every triumph and tragedy, every discovery and dream, has taken place on a tiny world orbiting an ordinary star, tucked away in a quiet arm of a spiral galaxy among hundreds of billions of others. The universe is vast beyond comprehension, and our place within it infinitesimally small. Yet, paradoxically, our very awareness gives that vastness meaning. Through us, the cosmos looks back at itself and whispers, "I exist." Our existence is fragile in every sense. Life depends on an intricate web of coincidences, the exact distance of Earth from the Sun, the balance of gravity and atmosphere, the shielding magnetic field that protects us from cosmic radiation. A fraction of a degree, a shift in chemistry, a stray impact from space, and the entire miracle of life could vanish. We live, suspended between chaos and order, held aloft by the most delicate harmony imaginable. And yet, from that fragility arises something profound. Life is not a flaw in the universe, it is its flowering. Against impossible odds, matter learned to think. Atoms arrange themselves into beings capable of curiosity, love, and imagination. From the same elements that form stars, consciousness bloomed, and with it came stories, music, art, and the quiet wonder of asking why. But even this awareness is temporary. The sun that warms us will one day swell into a red giant, swallowing Mercury and Venus, and rendering Earth uninhabitable. Our species, if it endures, will have to find a new home among the stars, and even then, the stars themselves will fade, the galaxies will grow dark. The universe will continue on, indifferent to our survival. Yet that doesn't make our existence meaningless, it makes it miraculous. The brevity of life gives it value. The fleeting nature of consciousness makes every thought, every act of kindness, every discovery, precious beyond measure. Like the brief flare of a star before it dims, our moment shines brighter because it will not last forever. Perhaps that is the greatest paradox of all, that in a universe destined for silence, awareness arose. Fragile, fleeting, but real. That from chaos came order, from matter came mind, and from mind came meaning. So, when you gaze up at the stars, remember, you are seeing the past, the same light that guided the first humans who ever looked upward in wonder. They too felt small. They too searched for purpose in the vastness, and still, through the immensity of time and the fragility of being, that same wonder endures. We are temporary, yes, but in our briefness lies beauty. The universe may forget our names, but for now, in this fleeting moment, we are here, alive, aware, and luminous, like sparks drifting through the infinite night. Someday, humanity may send its descendants into intergalactic night, riding beams of light or bending space-time itself to see beyond the cosmic horizon. It is a dream as old as wonder itself, the desire to leave our cradle and touch the stars. From the moment the first humans looked upward, we have been voyagers in spirit, charting the heavens with eyes and imagination long before we could cross the seas of Earth. But someday, perhaps not soon, but inevitably, our journey will extend far beyond this small world. The cosmos will call us outward, not as tourists of space, but as participants in its unfolding story. Our first steps have already begun. Robotic emissaries, Voyager, Pioneer, New Horizons, have left the sun's domain, drifting quietly into the dark. Each carries a message, etched in metal and sound, telling whoever might find it who we were. They are the seeds of interstellar curiosity, tiny vessels of human wonder cast into the infinite. In time, they will pass beyond the reach of any star, sailing through a night that grows ever colder, carrying fragments of us with them. But these are only the first whispers of what may come. In the centuries ahead, humanity, or whatever we become, may harness the deep laws of physics to traverse the galaxy. Perhaps we will ride on solar sails, propelled by starlight and lasers across light years of emptiness. Or maybe we'll build fusion drives or antimatter engines, blazing paths through interstellar dust at a fraction of light speed. The journey will be long, but not impossible. After all, every destination begins as a dream that refuses to fade. Some theories even imagine ways to bend space-time itself, to create warp bubbles or Einstein-Rosen bridges, folding distance so that two distant points touch. These ideas remain speculative, but so once did flight, or radio, or space travel. The universe, after all, has no laws against imagination. It only asks that we obey its mathematics. And in that mathematics, there may yet be room for miracles. Perhaps one day, our descendants will stand on the shore of another galaxy, their ships glowing faintly against the cold intergalactic dark. The Milky Way, our home, will be a faint smear behind them, a memory of origin. They will live in the space between stars, building new worlds among the void, carrying the story of life forward into the next era of time. For even as the universe expands and cools, consciousness, born of stardust, may find a way to endure. Yet there is melancholy in this vision too. As dark energy drives galaxies apart, the stars will drift beyond reach. Even light will grow lonely. Future voyagers, billions of years from now, may sail through a universe that grows dimmer with every epoch, their journey one of both discovery and farewell. Still, humanity's spirit is not easily dimmed. To explore is not simply to move through space, it is to reach outward through curiosity, through courage, through imagination. Even when the last stars fade, that spark may remain. Perhaps we will send our consciousness into digital light, spreading ourselves across the cosmos as patterns of thought, as whispers of information traveling through eternity. And if someday we do reach beyond the cosmic horizon, what then? Maybe we will find other beings who made the same journey. Or maybe we will find nothing at all, only silence. But even then, the silence will not be empty. It will echo with the story of those who dared to leave their home and touch the infinite. For to voyage is to defy limitation, to say, even in the face of eternity, we were here. Stars may fade, galaxies may die, but as long as there are minds to dream, the journey will never end. Humanity will go on not as creatures of Earth, but as children of the cosmos, forever sailing the endless sea of light and time. For all its vastness, the universe remains hauntingly quiet. Maybe life is rare. Or maybe, like us, other civilizations are still listening, still dreaming. Every night, we gaze into a sky filled with possibilities. There are more stars in the observable universe than grains of sand on all the beaches of Earth. Around those stars orbit countless planets, billions of them, within habitable zones where conditions for life might flourish. Statistically, it seems impossible that we are alone. And yet, across all our searches, across all our signals and telescopes, the cosmos answers us only with silence. This mystery, why the universe appears empty despite its overwhelming potential for life, is known as the Fermi paradox. Named after physicist Enrico Fermi, who once asked, "Where is everybody?" It remains one of the most profound questions humanity has ever faced. If life can arise here, why not elsewhere? If civilizations can build technologies, why do we not see their lights, their signals, their traces among the stars? Perhaps life is exceedingly rare, a delicate flame that flickers only in the most improbable of conditions. It took nearly 4 billion years for life on Earth to evolve from simple cells to intelligent beings capable of sending messages into the void. Maybe intelligence itself is fragile, easily extinguished by war, by catastrophe, or by the limits of planetary survival. Civilizations might bloom and vanish before ever learning to reach out. Their signals lost in the noise of cosmic time. Or perhaps they are out there, but so far away that their light has yet to reach us. The universe is vast beyond comprehension, and even light, the fastest thing in existence, takes years, centuries, or millennia to cross its distances. We may simply be separated by expanses too great for communication, each world an isolated island in a dark, endless sea. There is also the possibility that they are listening, not speaking. Perhaps every intelligent species, upon first discovering the vastness of space, feels the same hesitation, the same quiet awe that makes them cautious. They send out small signals, then fall silent, fearing what might answer. In this way, the universe becomes a gallery of listeners, all waiting for someone else to speak first. A trillion eyes looking outward, none daring to break the stillness. The silence could also be deceptive. Maybe alien civilizations exist, but in forms we cannot recognize, beings of plasma, code, or quantum consciousness. Their communications might not use radio waves or light, but methods far beyond our understanding, whispering in the languages of gravity or dark matter. To them, we might be invisible, an uncontacted tribe on a cosmic shore. And yet, amid this vast silence, something extraordinary has already happened. On one small blue planet, life arose, learned to think, to love, to question, and to listen. We are proof that the universe can awaken, that consciousness can bloom from dust, and that means, perhaps, it can happen again. So we keep listening. Through vast arrays of radio telescopes, through spacecraft that scan the darkness, we reach out with patient curiosity. Every faint signal, every unexplained pulse of light, stirs a quiet hope that somewhere out there someone else is looking back. Until that day comes, if it ever does, the great silence remains both haunting and beautiful. It reminds us that even in loneliness, we are part of something immense. Perhaps we are the first to awaken, or perhaps we are merely early listeners in an unfinished cosmic symphony. And maybe, just maybe, across the immeasurable night, another mind wonders the same thing, if they too are alone. If they too are waiting for the silence to break. And when we finally reach the edge, if such a thing exists, perhaps we'll find that it was never about distance at all. It was about perspective. The edge of the universe is the edge of understanding. For as long as we have looked up, humanity has sought the edge, the horizon, the frontier, the limit. We climbed mountains to see beyond them, sailed oceans to find what lay past their ends, and pointed telescopes toward the heavens to glimpse the boundaries of existence itself. Each time we found more than we expected, not an ending, but a beginning. The cosmos seems to have no walls, only deeper layers of mystery. If we could travel to the farthest reaches of space, past the last galaxy, beyond even the light that has reached us since the dawn of time, we would not find a boundary. We would find curvature. Space would bend, fold, and return upon itself. The edge of the universe is not a wall to collide with, but a mirror to peer through, a reflection of our own desire to comprehend infinity. The deeper truth is that the limits we seek are not written into the stars. They are written into us. Every horizon we chase, every question we ask, pushes against the boundary of our perception. What we call the edge is where understanding gives way to wonder, where the known dissolves into the infinite unknown. In that sense, the edge of the universe is not out there among the galaxies. It is here, within the mind, where curiosity meets its own limitations. When we look at the night sky, we are not just seeing light from the past, we are seeing the edge of what is knowable. The cosmic horizon, the farthest distance light has travelled since the Big Bang, marks not the end of space, but the end of sight. Beyond it, the universe continues, unseen and perhaps unseeable. Yet the human mind, in its boundless imagination, reaches past even that. It wonders what lies beyond time, beyond existence itself. That is what makes us explorers, not our ability to travel, but our ability to imagine what we cannot reach. Every great discovery, every leap in science, art, and thought has come from someone standing at that edge and refusing to turn away. When Newton saw the apple fall, when Galileo lifted his telescope, when Einstein dreamed of riding a beam of light, they each pushed the edge of understanding further outward, expanding the universe not through motion, but through insight. We are their descendants, continuing that endless pursuit of the horizon. Perhaps one day we will reach the true boundary, the moment where the universe stops expanding, or folds back into itself, or gives birth to another beyond it. But even then, the quest will not end, because the journey has never truly been about finding edges. It has always been about what lies just beyond them, a new question, a new mystery, a new way of seeing. The universe, in its infinite vastness, is both the mirror and the canvas of our curiosity. Its edges shift as we evolve, always just beyond our reach, inviting us to keep reaching. And maybe that is the most beautiful truth of all, that there is no final horizon, no last frontier, only the ongoing act of discovery itself. At the edge of everything, we find not emptiness, but reflection. The universe, vast and silent, looks back at us, and in that reflection, we see ourselves, the seekers, the questioners, the brief sparks of consciousness daring to touch infinity.